Good morning, distinguished guests and scientists. Ladies and gentlemen, we believe that it's crucial for the local scientific community to share and exchange new ideas and research work with that from abroad, we significantly help Viet Nam accelerate international integration. The 9th International Conference on Contextual System Application, ICCASA 2020, takes place on cyberspace due to the widespread epidemic COVID-19 around the world. Travel was limited. It's co-organized by European Alliance for Innovation and Western University. In organizing the conference, we are also ordered to have been well guided and supported by both the co-organizer. We are happy to see the conference has attracted various prominent scientists from over 8 countries worldwide, and welcome your innovative idea and research work on the contextual system application in attempt to formalize a new computing system in the future. On behalf of the co-organizer, we would like to take this opportunity to express our sincere appreciation to all the participants and the co-organizer for their valuable and continued guidance, support, and cooperation with are indispensable for the success in this event. We wish you would have happiness and every success in your career and development, especially in the future, in further research in the field, and further accelerate the development of competition. Thank you for your attendance.
Dear ladies and gentlemen, let me welcome you to the EAI ICCASA 2020 9th EAI International Conference on Context-Aware Systems and Applications. I am Aleksandra Śledziejowska, the EAI Conference Manager of ICCASA 2020. Unfortunately, due to the virus, I am not able to meet all of you in person, so I am using this opportunity to address the organizing committee, the keynote speakers, the authors, and the participants on behalf of EAI. First of all, I would like to thank all of you for being a part of this conference and for your involvement with EAI. Above all, I would like to express my gratitude to the General Chair, Professor Phan Vinh, for his hard and excellent work throughout the whole process of the conference preparation. During today's event, you can actively participate in two ways. Firstly, you can join the Q&A on Slack through a link that you can see below this video. Upon accessing the EAI ICCASA 2020 Slack workspace, you can enter the channel called Discussion. Secondly, you can vote on individual presentations and leave your fellow researchers' feedback on their work through EAI Compass. We will shortly show you how you can access these platforms and how to leave and receive feedback for presentations in this conference. I would also like to use this message to invite you to join us again soon. Therefore, I am glad to announce that the next edition of the conference will take place in November in Ho Chi Minh City in Vietnam. I invite all of you to participate in ICCASA 2021. Should you be interested in being a part of the Technical Program Committee, please do not hesitate to contact me at my email address below. Similarly, if you are interested in discussing other possible cooperation, organizing a conference or a workshop, please contact me at my email address as well. To sum up, it is our honor to organize this year's edition of ICCASA Conference. I hope you will have a wonderful time during this event and that you will follow the next edition in 2021. We will keep you posted and the news about this event will be available on the conference website. Now, my colleague Michal will talk more about the EAI tools and go into more details about the aforementioned voting. Thank you for your attention and enjoy EAI ICCASA 2020. I hope to welcome you again next year in Vietnam.
Hi everyone, my name is Michal Dudic. I'm the Community Manager at EAI, European Alliance for Innovation. It's my pleasure to welcome you at this conference and say a few words about who we are and what we can do for you and your research career. In short, EAI is a global community for a greener, healthier and smarter world. As of today, we are home to more than 60,000 members from 167 countries, and we reach out to tens of thousands of subscribers. As an organization, we are non-profit from day one, and what is most important to us is that we remain open to all researchers from all around the world thanks to membership that is completely free. We organize more than 100 events annually, such as this conference, and we do so in publishing partnership with Springer. I said in the beginning that EAI is a community, so let's talk about what that means and what it means for you. To put it briefly, we give our members a platform that builds their research. We do it with 3 main online community services where members come together to help each other write a better paper, get an objective review, and get recognized fairly. The 3 services in question are EAI Compass, Community Review, and EAI Index. Firstly, EAI Compass is an online app where you can meet and connect with new colleagues and get feedback on your paper as well as your presentation. In addition to that, it lets you download all full papers that will be presented at this conference, and you can vote on your favorite presentations as well as see everyone who is here and connect with them. You can do this right now if you go to EAI Compass website, compass.eai.eu. Next, we are improving the classic conference review process with community review. It has already been in use at all our events since 2019, and we were very excited to hear a lot of positive feedback from program committee members regarding the reliability and the speed of the community review. Let's talk briefly about what community review does. Essentially, it is a website that shows abstracts of papers that are right in the middle of the review process, as long as the authors allow it, of course, and all EAI members may then bid to review specific papers. When they submit their bid, they put in their bio and their qualifications, which are sent to the program committee, who can then decide whether or not this bidder is qualified to review the paper they bid on. This relatively easy access to review opportunities means that bidders really need to put their best foot forward if they wish to be selected, which improves the quality of the entire review process. At the end of the day, this benefits you, the author. And last but not least, let me tell you a thing or two about EAI Index. EAI Index is our credit-based evaluation system that we rolled out this year to all of our conferences and journals that allow you to climb the global ranks of EAI community and get recognized for your work. It calculates a number value for most actions you make, such as getting your paper accepted or submitting a review, and these numbers accumulate for 12 months. At the end of this 12-month period, we put together a ladder of all EAI members, and the ones at the top receive a nomination to one of the membership ranks: senior member, distinguished member, or fellow. For each action that is eligible for EAI Index credits, we'll look at the quality of your action as it was evaluated by another member of the community, such as, for example, the review score of your submission. To make sure that the system is fair to newcomers, every 12 months the credit count gets erased, the ones at the top receive their nominations, and every member starts at 0 for the following 12 months. And finally, Smart Submit is a collaboration feature that is coming later this year. It will allow you to submit your research ideas and your work in progress abstracts to get the kind of help and feedback you're looking for. Maybe you are looking for co-authors, maybe you would like to find a mentor or a mentee, or maybe you want to find out how the community feels about your idea. This is what Smart Submit is designed for. Ultimately, it's about helping you write a better paper and increasing your chances of getting accepted. Again, we will be launching this feature later this year, so stay tuned. And so I'm going to leave you with many different ways to get engaged at different levels. There are lots of opportunities in many of our events and publications, which means many ways to connect with people and collaborate. You may learn more about everything I just talked about at our website, eai.eu. These services exist to help you and to make your lives easier, so we encourage you to send us your comments, ideas, and feedback to community@eai.eu. And if you're interested in volunteering and contributing, you can let us know at the same email address. Don't forget that you can use EAI Compass to vote on presentations in real time to determine which ones are the best, as well as to download all full papers that will be presented today. Just make sure that you log in using the same email address as the one you used to register to this conference. Thank you very much for your attention. Please enjoy the conference, and I hope we will see everyone online soon.
สวัสดีค่ะ Hello, everyone. I'm saying hi to you guys from Bangkok, Thailand. I'm Waralak Vongdoiwang Siricharoen. Thank you very much and very honored to be the keynote speaker of ICCASA 2020 this year. Even we couldn't be together as the pandemic COVID-19, and I'm wishing you all very well and be safe. I'm doing very well here in Bangkok, and I hope that next year we're gonna meet for the next ICCASA 2021. All right, so I'm gonna get to my talk today. Introduce you just a little bit about the concept of empathy mappings and persona. So I would like to show you the slide. This is what I would like to introduce you to, that this is my name. You guys can call me Lak, and I think some of you are already familiar with me. And I'm working at the Siricharoen University in Bangkok, Thailand. Actually, we have many campuses in Phetchaburi, in Nakhon Pathom, Bangkok, and also Nonthaburi. So we are very welcome you if you come to Bangkok when this COVID thing is over. Okay, so the talk that I would like to introduce you to today is using empathy mapping in design thinking process for the persona discovering. The topic of this talk is going to be related to some of the concepts like persona, design thinking, empathy, SEI, which is human-computer interactions, and user-centered design. For the abstracts of the talk is I would like to, as a conclusions, exploring the user attitudes and behaviors can help user experiencing team to match the user with the deeper understandings. And design thinking is, I would say, the new and groundbreaking approach of how we can work together, collaborative approach to problem solving and also putting the users first to make the user-centered design products or the services or even the software. So this is many variants of the design thinking activities that used to generate the thoughtful of the users or the customer, including the concept of the persona. So the persona concept, the main goal of the persona is to help someone imagine the intended users of the system. So it's very important to understand, whether this product or software or the service gonna be useful for some source of the users, or we call the persona. The persona can use this as a tool as well to discussing about the advice, about the storytelling, even using as a role playing to dig out some of the problems and how we can solve it in a very extreme way. So the persona can also help, the new designer in the team to learn quickly what kind of user that they want to describe in specific, not everyday user, not every end users as well. So the designer create the models that can represent end users, and the persona are also the tools that are also used in many parts of the interaction design, UX and UI. So as follow, like in requirement, if you are in the software engineering design and you want to dig out some of the requirement, that what is the functions or what is the system that the user want to work with. So you need to understand the wants and explain user in a very clear way. And design process, you can use this to understand what the persona need. For the evaluation, you can detect needs that are or are not being encountered, or even in the marketing, which is you need to acquire the new customers. You need to aim for the user needs that have already been recognized and intended for. And the personas are used intensively by human-computer interaction or SCI designer within the design process to do two things. The first one, to defining the target user, to explaining what you understand about the persona, to help designing process in a very different stage of planning it. And the second one is to illustrate the design process of the model in order to reflect the organizational problems, or to systematically explore the design options to considering the differences of the people, like expectations, scope, or goal that related along the way of the process, such as the roles of the needs, requirements, and necessities. The designer can use a small number of the people. The persona sometimes can be imaginary descriptions of the persona who is truly exists. So it can be real or not real. The persona can be true in real life, of course, and can be used that particular persona is appropriate if the designer wants to create some of the personality profile of some particular persona. And it's as detailed as possible for the fictional agents of the target audience can be created. The personas are the people that represents a group of the people that have different needs, objectives, and expectations. The persona may help designers to, merchandise owner decide whether the product or the service will slot into their daily life or daily activity or daily wants, with some providing transparent pictures of that person's user experience sections. And personnel also are very useful once a prototype test had taken and appeared at the end to find the problems, and we will face it in the system flow. So you can fix it if you know exactly what the problem is. This is the example of one persona like Sandy from India. He's had a biography, he is a scholar, he has a lot of experience, and also he has some kind of the personality test. Developer would like to understand as much as they can that we use who is the user and get to use and see what they are going to use the product or that service that they decide for. And knowing the audience can help, developer solutions and the real reason that the user want from that particular product. So some interesting inquiry to ask when checking out the persona in design concept are: who is the ideal customer? And what is the present behavior of the user? What is going to our user look like? And what are the requirements and the final goals of the user? What is the answer to their current problems? And why do they hate the current solutions? Sorry, sometimes I would say the technical problem can be occurred. Okay. I'm sorry, may I just pausing just a bit? Sorry, so you can get back to the talk now. So we understanding the requirements of the users and where it can be created the products that serve it better. So, sorry. All right, I'm just checking the VR or your recording, I'm sorry. And keep the persona as 4 or 3. I'm sorry, get back here, I'm sorry. Understanding the requirement of the user well, it can create the product that and the service better. So the transparent personality of the user that we can see through in the design thinking will assist the designer identify user needs and communicate better with them to find what is the proper solutions. And before we defining the identity of the user, designer just want to study the users and their behavior well and gather enough data, enough knowledge to organize the infos and make the ideal customer. So keep the persona to minimum 3 or 4 for the good persona. If designer can manage 2 things better than all, it should not exceed 5 person or 5 people. It will be there to clarify the target audience, and that it can make it more difficult in personalities. Even, like even the situation, large online store, they can have a very diverse product range from, like many kinds of the customer. But can you believe it? The persona, like 3 persona can be enough, or 4 can be enough. If you have a good persona, can be identify the real users of that large online store. For the good persona, is only 2 criteria. The first one, they must live inside the mind of the reader when they read their descriptions, and they must be correct. Yep. So we can easily confirm the first point of the good persona. The first one, does the description make a good impression on the persona? And the second one, do we feel like we can organize them if we meet them on the street? Recognize them, kind of, but did we know that exactly persona that we want? And have this coworker neutral and ask these questions if we are not sure that who we are. And it is a little harder when you're talking about the second issue. In order to test this, we need to study the user research and market research again. And the last one, do they match the description that we created, so we can know that this is a good persona. And the persona seem to feel like through the perfect design. For example, like we creating Willie. Willie is 55 years old. He's employee in the financial department of the bank. No children. As a technical supporter, he's also give the people advice all the time about using device, which is the persona might exist or not very much in real life. That's why the Willie is not a very good persona. It's got to be more, like the specific one. It's because it's more look like the real person, but we want the persona that like kind of imaginary user. So this is one of very popular step 10, step 2, finding the persona by Lynn Nielsen. The first one, we gather as much as knowledge as we can. And the second one, begin to create general concepts about the variant user within the focus area. And the third one, to design whether to support or reject assumption of differences between users. And the fourth one, design the appropriate number of the final persona, which is probably, as I told you, not more than 5. And make sure to show enough understanding and attention to that particular user. 6, it should be a list of needs, including a list of the situation which the product and service will be used. And the second, accept by the organization and recognize the group of the like stakeholder as much as possible to accept, acknowledge that you already gathered. And the 8, this is important to decide first that what we want to share this knowledge to, who they are that we want to share with, probably new employee or the external partner in the future. And number 9, to create a situation for you, if you get a better understanding of the problem this individual want to solve. So when we show this situation, is you have a proof that we have a lot of common in order to this particular persona want to get out of the problem. And number 10, the designer should editing the descriptions commonly as the new information. As you have some designer will have to write the explanation of existing identity and add a new personality or get rid of outdated words. It's kind of like rewrite it and wrapping all the necessary information. The second one, we already talked about the persona in the first part. The second part is about the empathy in design thinking. Empathy is good to examine the world through the judgment of the others, I would say, and to confirm what they see and feel about things or what are they doing. So of course, like no one feel like what the other people do, right? But at least we plan to do it as much as possible to put into their shoes. And we will do so by placing the prejudice, ideas, and selecting to know the thoughts and desires of the other that is placed. So there's some kind of the design thinking framework. It have like a step and the way that we digging out into each one of it. In design thinking, the empathy is described in the ideal human-centered design toolkit, which is the deep understanding of the issue and the realities of the persona we are designing. So we learned about need and that person faces, and as well as also the revealing their hidden needs and wants to explain their behavior. In doing so, it is good to have like sympathetics of the people's situations, including the role and cooperation in their real environment. And the empathy helps designer gain the greater appreciation and insight about the person's expressive and physical desire. Therefore, the way that they perceive and realize the corroborate of the the things around them and helping to find what is the motivate them and what make them better, or what do they like and what do they do. So empathy is the first step of planning, design, thinking process. And the next step would be like define, ideate, prototype, and testing. Is kind of exploring and experiments and doing like iterative process again and again until you got the best one. The goal as a designer is to aware of exact sympathetics of the persona which are decided and therefore the problems that we are trying to solve. And this process involves detecting, appealing, and giving the attention to the persona, which are designed in order to get to know their experience and motivation, as I told you before, as well as being occupied in their own physical situations. So attention is very important in the user-centered design process. And design thinking and attention will help design thinker who creating the process build their expectations about the world, to understand user and their needs from time to time. And the person must gather as much as information that they want within the empathizing process of design thinking process. We need to develop understanding, experience, insights, and observation that the user or the person will use. And designer need to develop the easiest possible understanding of our users and their needs. So the person will be surprised that the persona and the team will get through the empathize method. So this is some popular empathize method, for example, like ask what and why, ask 5 why, interviews, and sympathetic interviews, and build this empathy by comparing, take education using photo and video, using the personal journal and also the personal photo, personal video, and very engaging with the user, be with them, share the story, capture image, and body storm, creating traveling maps, all that. So the sympathy is the word that often confused, but it's about the power of the person to have and to show what concern in the other people's well-being, why compassion doesn't need to experience that. So in the deep, in what persona, in addition, compassion is often associated with the feelings of the impartiality and advantage. But when we feel compassion, we tend to point out the compassion and the grief of the others. So it's kind of like you need to feeling into their shoes, what is the pain point and what is the gain point. That's why I'm going to introduce you to the empathy map. The empathy map is the collaboration visualization used to identify what we know about a certain type of the users, and it transmits the knowledge about the user outside, like creating the common understanding and help them make decisions. So you can see this is empathy map, which is have like 6 topics: think, feel, hear, and see, and also say and do, and pain point and the gain point. So this is the persona empathy mapping. This process simplifies the category to 3 main issues, like think, feel, do. And the zeros persons, like the first of everything is on the persona within the specific situation that we, like want to get the product domain and specific user into the group. So in the empathy map, also provide in-depth content with what users are saying, thinking, feeling, and doing while accessing the service and products. The key benefit that I discovered from using intention map is the easy to update about each round of the research. They focus on specific only user experience and behavior. It's also easy to refer, like within the playing field or within the domain of that we specific the situation for, and help the team think that our users are the real people. So after, like filling out of this 6 area here, the empathy map design can get, like comprehensive information about the users, and each persona should include all of this basic element that reflect this map area. Additional specific information about imaginary user, and every map character will turning into the persona should represent the person which it will be easier to understand during the design process. So as a conclusions, thank you very much for listening to me until the last part of my talk. The idea of the designing or developing within using the persona can be very difficult. The more we know about the users, the better the product and service or the software will be. That is why the person or the people help, like everyone on the team can focus and occupy on specific users. A user-centered design has great benefit to the people because it's the first to be considered. We pay attention, the whole attention to the users. So the personnel development means living in the state that needed and improve, like how the people, even they're not unrealistic, but they can be understand as a product or the person that gonna consume that particular product. Yep. And nevertheless, if the real data and knowledge of the user is from the call, and there are every purpose to advise oneself or to improve them. So the benefit of the persona are the powerful. If you see here from the Stanford School design thinking process on the empathize, maps here, or we call the empathize method. It can be creating by interviewing, shadowing, seeks to understand and non-judgmental at all. Then you're gonna have a very good defined personas right here. In this core design, see the relations and the connection between empathize mapping and the persona. So the empathy map are the great for creating the persona and identifying the user with different intentions and being a collaborative tools. So empathy mapping can help us consider how the other things in the field, and the persona empathy mapping is very useful as a sympathetic workshop activity and align with the needs of the target users with the pain point that they, connected channel with the person creating the products and the software. Also, interpersonal and design concept. Designer create the rotations for the empathy mapping by focusing on the persona during the combination of the workshop with the other stakeholder. So the other stakeholder can understand what the user could be feel or what the user can be experience the problem. So this is I think it's a useful technique for helping finding some of the good persona. And thank you very much for being with me today. And I hope you guys have a very beautiful day on ICCASA 2020. And I wish the best for the organizer of the conference. Thank you very much for inviting me again to be the keynote speaker here or there. Be safe and we are in this together. And I wish you very well. all of you. Thank you very much. Goodbye. สวัสดีค่ะ
Hello everyone, welcome to my presentation. Today I would like to present my paper with the title Formal Verification of Anti-Agent Plans for Vehicle Platooning. Here is an outline. First, I would like to introduce about ELISA and why do we want to convert the ELISA plans into modern checking formalisms. Secondly, I explain about the modes and ELISA plans for the case study. Next, I explain the vehicle platooning in the UPA model checker after translating from the ELISA plan and its verification results. Lastly, I talk about the conclusion and our future work. ELISA is an abbreviation for a language interactive cooperative agents. The language and engine are using to control our agents based on the plans called ELISA plan. As a safety verification, we need to verify the plans for our agents before deploying them in the real world, particularly when they collaborate with the other agents. Therefore, we use a modern checker to demonstrate that the agents always behave according to the requirements and never choose options that end up in an unsafe situation. Unfortunately, the process of converting the plans into modern checking formalism is not only difficult but also requires consistency of designers. For example, the transition is used in plan A and plan B and so on. When it is transferred into UPA, it must be translated in the same way, though it can be translated by different designers. The solution is that we create and develop a 2U translator. We can automatically translate ELISA plans into UPA syntax to solve the problem. For example, in the figure, as you can see, the state in ELISA can be translated into normal location like this. Note that it is not always translated one-to-one, depending on the behavior of plans that are inhabited in the state. It can be translated in the normal location, connect with the committed location like this, or urgent location. In this example, the forming plan here can translate it into UPA at the same template with the create platoon, or can be translated and moved to the new template here. In this slide, I explained about the mode for ELISA plans. Totally, we have 9 modes. The first mode is the searching. You can see here the Discover 1 and the Discover 2 vehicles are the free vehicle. If they have the same goals, they make a platoon, or they can join an existing platoon. If they create a platoon, they move to the forming mode. In this model, they decide which one will be the leader or follower of the platoon. The vehicle having the higher safety index will move to the leading mode. That means it is a leader. Once it is a leader, it can steer the following vehicle, send information, keep track of the list of the followers, and accept new vehicles. And the vehicle having the lower safety index will move into the following mode. In the following mode, all vehicles drive autonomously and follow the leader. A follower can receive information from the leader or transmit information to the other members of a platoon. if the platoon has at least 4 members, it can split into the smaller platoon, and at least 2 of the members have the common goal. The new leader will be chosen from follower vehicle. In this case, you can see the new leader will be chosen between the follower 2 and follower 3. If the leader 2 no longer has any member, after dividing the platoon, it will move to the dissolving mode. Otherwise, it continues to lead the platoon with the remaining members. At the joining mode, the leader of an available platoon has found a free vehicle that wants to join. It sends a joining request to the free vehicle. In this case, it discover one, for example, and the discover one have to be accepted within a certain time interval. All vehicle can request to leave a platoon at any time. In this case, they will move to leaving mode. For example, when they have reached their goal, if a member of platoon leaves, it must send a leaving request to the leader, and it only can leave when it receives an authorization from the leaders. And if the platoon has only 1 member and the leader leaves, and then the remaining member also will move the dissolving mode. The last mode is negotiation. When a non-member vehicle wants to join an existing platoon, for example, the recover one wants to join this platoon, and it had negotiated the leadership with the current leader. In this example, is the leader 1. Either the recover one become a follower or new leader. The leader of 2 or more platoons that want to merge also can trigger the leadership negotiation. In this case, based on the 9 modes, we create the ELISA plan for vehicle platooning. As so in this figure, you can see here. Here is the searching mode, joining mode, forming, negotiate leader. If it is leader, it move to the leading state and execute the leader plan. If it is a follower, it move into the follower state and execute the following plan, and so on. You can see here on the mode is here. Okay, now even we have tested the plan many times, the plan still can contain the sophisticated errors that can lead our agent to violate the safety requirements, such as deadlock or time requirements. Therefore, in order to show that the ELISA plans are absence of above problem, we use UPA model checker to refine the plans. Of course, of course, we have to translate our ALISA plans into UPA model checker formalism to verify. And here is the resource. After translating, you can see here's 9 mode, and here for me searching, for me following, and so on. Finally, we can verify required properties for our plans. First, I want to verify that if an agent is a leader, then its safety index must be the highest in all other vehicles involved in its platoon. This property is formulated for vehicle 2, abbreviated as V2, you can see here. Also, this property expresses that in unreachable states, this is for unreachable states. If V2 is in leading location, that means its safety index is greater or equal to all members of its platoon. Here an array safety-IDH contains the safety index of all platoon members of V2. The next interesting property is whether the vehicle with the highest safety index starts joining in the platoon is always ends up being a leader. To express the liveness property, we use a lead to or response form. It is written in an arrow here. Here in this scenario, we assume that the V1 has the highest safety index, and whenever it is in the start location, finally it will move into the leading location. That means V1 now it is a leader. Similarly, we check if two platoons want to merge. The leader negotiation is triggered, and the one having the higher safety index will be the leader. In this scenario, we assume that the vehicle V4 and V5 are the leader, and they move into the leader location in order to compare their safety index. And finally, the V4 will move into the leading location. That means now V4 is a leader of the new platoon. And here is the variable id-new-leader of V5 equal to 4 to indicate that now the leader for vehicle 5 is vehicle 4. Note that I do not explain all properties which were verified by UPA in my presentation. In this slide, I talk about the conclusion and our future work. The first advantage when we use A2LE to save time and have reduced modeling errors, it also helps us improve the efficiency and the consistency of the modeling process. However, so far many features in ALISA still cannot convert into UPA. For example, there are 6 rules in ALISA engine, and so far A2U only can deal with 2 rules. Or plan type, quality plan. In this case study, we only use plan like forming or negotiation leader. They are plan, they are not plan type. At the future work, obviously, we want to add more features from ALISA engine for A2U. We also want to refine the ALISA vehicle platooning plan in order to avoid the state space exploration. The most ambitious future work is we want to create model checker that can verify ALICE plans or hierarchical state mergings without flooding them. Thank you for the kind attention. We'll now move on to the question and answer. And now, if anyone has any questions, I would be happy to answer.
Assalamu alaikum. My name is Salwa Muhammad Akhtar. I'm here to present my work, Contextual Defeasible Reasoning Framework for Heterogeneous System. This is my MS thesis work, which I'm currently doing under the kind supervision of Dr. Mahfuzul Haq. During the course of this presentation, we will first discuss certain terminologies about our framework. Then we will discuss the working and the development of our framework. And at the end, we will discuss a case study, which is the smart healthcare system, which we have developed to check the validity of our framework. Context-aware systems nowadays have garnered a lot of attention in our everyday life as they use personalized smart devices to acquire contextual information, perform reasoning on it, interact with each other, and then adapt their behavior accordingly, thus providing us with customized information or services at any time and anywhere. Now let's talk about what do we mean by context in context-aware systems. Context includes any information that can be used to characterize the situation of an entity. This entity can be a person, it can be an application or a device. Now, context awareness is the ability of a system or a device or an application to adapt its behavior according to its environment. On the other hand, context-aware system is responsible for collecting contextual information from its environments with the help from sensors or agents, perform reasoning on the collected information, and then adapt its behavior accordingly as a whole. Now, in order for the context-aware systems to perform reasoning on the data, they can use various reasoning mechanism or logics, for example, first-order logic or BDI reasoning. Now, in our framework, we have opted for a rule-based reasoning approach. Particularly, we have written the rules in the Horn Clause rules format. Now, our reason for choosing rule-based reasoning approach was due to its simplicity and efficiency. One such rule is provided over here. Now, this rule states that if there is a person and her name is, for example, Alice, and this person Alice has a patient ID P001, then this rule concludes that the person Alice having a patient ID is a patient whose name is Alice. Now let's talk about what do we mean by multi-context systems. Now, multi-context system is basically a collection of contexts. These contexts can be anything. It can be a bunch of ontologies, it can be databases, it can be independent domains, it can be independent knowledge sources. Now, all these contexts in a multi-context system communicate with each other using inference rules. When such independent domains are communicating with each other, sometimes an inconsistency occurs. An inconsistency occurs when we have different contradictory information from two separate domains. In such situations, the system as a whole is unable to reach a conclusion, and the system is rendered inconsistent. An inconsistent system is unable to reach a conclusion, therefore it becomes useless. We're trying to resolve the inconsistency issue in a multi-context system using contextual defeasible reasoning. Now, contextual defeasible reasoning is a distributed rule-based reasoning approach which uses a defeasible logic to defeat the conflicting evidence. Now, in defeasible logic, we have a priority relation or a superiority relation. This relation is applied on the different rules which are involved in the system. So the rule with the higher priority is considered, whereas the rule with the lower priority is discarded in case two rules who bring us contradictory information occurs. Over the past years, many authors and researchers have worked towards solving the inconsistency issues in different multi-context systems. Some have used preference-based ordering approach to resolve inconsistencies in peer-to-peer systems. Some have combined arbitrary monotonic and non-monotonic logics using bridge rules. Now, our work is different from the previous works because, to the best of our knowledge, this approach has not been proposed, in which context-aware agents use contextual defeasible reasoning-based formalism to model the flow of information among different contexts and handle inconsistencies using a defeasible reasoning approach. In our proposed framework, we have modeled our system using ontologies. We are extracting the rules from these ontologies, and these are the rules which are used by our context-aware agents in order to perform reasoning and in order to share data with each other. We have illustrated the use of our proposed framework with a simple example and its prototypical implementation using Python programming language. Now we just discussed that we have developed ontologies in order to model our system. We have basically developed two separate ontologies. The first one is the smart home ontology and the second one is the smart hospital ontology. And we have chosen OWL2RL ontology language and semantic web rule language to develop these ontologies and develop the complex rules for each specialized domain. The reason for choosing these OWL2RL and semantic web rule language was its reasoning capability, genericity, extensibility, and expressiveness. These ontologies which we have developed are extremely extensive in nature, so fragments of these ontologies are shown over here. As you can see that the entities and their relationships can be easily identified from here. Now, there are different agents which are involved in our framework. These context-aware agents, our system, a context-aware system, is basically composed of a set of rule-based agents, and these agents are gathering data from their environment and performing reasoning on that data and then sharing that data with each other. They are doing all this with the help of rules. So basically what our agents do is they are performing three core actions. The first one is the rule. Now this action is performed every time a rule is used by the agent. A strict rule, a defeasible rule, a mapping rule, a communication rule. These rules can be used, for example, strict and defeasible rules are used for performing reasoning on the data it has collected. So whenever such a situation occurs, the rule action is performed by the agent. Now the copy action is performed by the agent, which is the second action, whenever two agents are communicating with each other, whenever they are sharing data with each other. Whereas the third action, which is the idle action, it allows agents to remain in an idle state, but transit to the next state is triggered by the system. Now, as we have discussed earlier, that defeasible logic is used by contextual defeasible reasoning to defeat conflicting information, and defeasible logic has a priority relation or superiority relations on the rules which are involved. So the system performs defeasible reasoning non-deterministically, whereas the rule priorities are static in nature and they are set by the system designer at the time of the system design in order to avoid inconsistent behavior of the system. This is a very generic figure or architecture diagram of our proposed framework. There are three layers in it. This is a bottom-up approach. So the first layer is the semantic knowledge layer, which consists of various ontologies which we have developed or which could be developed. The second layer is the multi-context layer. Now from each ontology developed in the semantic knowledge layer, a corresponding context can be developed by extracting facts and rules from the ontology. Now these contexts, they have agents of their own which are responsible for collecting, processing, and sharing data with each other. And these contexts, when they start communicating with each other, they form a multi-context system. Hence, this multi-context layer is formed. When these contexts are communicating with each other and an inconsistency occurs when, for example, contradictory or incomplete information is obtained, then the third layer, which is the agent's modeling and reasoning layer, is activated, where contextual defeasible reasoning is used to resolve these inconsistencies. These inconsistencies are resolved by checking the priorities of the rules which are responsible for causing the inconsistencies, and the rule with the higher priority is saved, whereas the rule with the lower priority is discarded. Now, our proposed framework can be used on any domain, but we have opted for a healthcare domain. We have proposed a case study on the healthcare domain, and we have particularly focused on the patients who are suffering from Parkinson's disease. Parkinson's disease patients suffer from two major symptoms. The first one is the seizure and the second one is the memory loss. Both of these symptoms can be very dangerous in critical situations because in an emergency situation, if a Parkinson's disease patient is having a seizure, that means they can't run away from danger. And sometimes even if they can run away from danger and due to the memory loss, they forget that what are the options they have and where are they supposed to go, this could be a dangerous thing as well. If a situation occurs and they don't remember what to do in that situation, that could be dangerous for them as well. So we have proposed a smart healthcare system consisting of a smart hospital system and a smart home system, which are continuously monitoring the Parkinson's disease patient's surroundings and their physiological responses. The smart home system is responsible for monitoring the carbon dioxide, carbon monoxide, and room temperature levels in the patient's home, whereas the smart hospital system consists of a device which is worn by the patient, which is continuously monitoring the heart rate, blood pressure, body temperature, EEG, ECG, and EMG of the patient. In case any abnormalities in these levels occurs, and the relevant authorities are alerted by sending a SMS, email, or notification alert. Before we discuss the generic figure or the generic architecture of our framework, this is a very specific architecture of our proposed work, because this is the architecture of our case study, the smart healthcare system. We have two ontologies, the smart home and the smart hospital ontology. We have extracted rules and facts from these ontologies and developed their corresponding contexts, which is the smart home context and the smart hospital context, respectively. These contexts have agents of their own. When these contexts communicate with one another and an inconsistency occurs, then we use contextual defeasible reasoning to resolve this issue. We have done a prototypical implementation of our proposed work to check the correctness of our work. In order to do that, we have developed agents using the Notepad++ code editor and Python programming language. Each of these agents are, as the code states, is basically generating random values from within a given provided range. Here we have a heart rate agent, which is randomly generating values from 0 to 200. Now these values were obtained by going through several medical literature articles which contained ranges of the physiological responses of the human body. So here we have a heart rate sensor or agent, which is generating random values from 0 to 200. Now, after generating these values, this heart rate agent is sending these values here to the ThinkSpeak platform. The ThinkSpeak platform is a platform which allows you to receive data from multiple sources and then react or perform actions on the data that is obtained. So we have developed two channels on the ThinkSpeak platform. The first channel is for the smart home context and the second one is for the smart hospital context. Here we have a screenshot of the smart home context, which is one of the channels for the ThinkSpeak platforms we developed. And over here we have the field 1 chart, which is obtaining information from the carbon dioxide level monitoring agent embedded in the patient's home. And we have certain points over here, and next to it is a gauge which is telling us the current value and whether it is in the normal range, which is the green one, orange range, which is the slightly dangerous one, or red range, which is the extremely dangerous one. Now, ThinkSpeak also allows you to react or perform action on the data that you have collected. This can be done by using the ThinkSpeak React application. We have used 3 ThinkSpeak Reacts for sending email, for sending notification, and for sending SMS alerts to the relevant persons. We have put together certain values, certain data conditions, which whenever they are met, these Reacts would be triggered. Now, in order to send the SMS and the notification, the Twilio and the IFTTT platforms were used. We had to find a way to connect them to the ThinkSpeak platform, which was done using the ThinkSpeak HTTP application. It allows you to form a connection or to connect with other services outside of ThinkSpeak. So here we have 2 screenshots. One is of the ThinkSpeak React, the other is of the ThinkSpeak HTTP. The one on the left, the first one, which is the screenshot for the ThinkSpeak React, is about the heart rate agent, and according to it, the condition, which is the second last line, it says whenever the heart rate is above 120, in such a case, this react is occurred. That means we receive some sort of a reaction, which is the ThinkSpeak HTTP, which we have done over here, which means that IFTTT is triggered. The IFTTT ThinkSpeak is HTTP is triggered, and a notification is generated every time the heart rate goes beyond 120 beats per minute. This is the MATLAB code we have written to generate an email. With MATLAB, we didn't really have to connect it using the ThinkSpeak HTTP because it was already embedded in ThinkSpeak. The persons who were responsible for creating ThinkSpeak also created MATLAB, so they were able to automatically or embed MATLAB in ThinkSpeak beforehand. So all we had to do was just write this code and an email was generated. Now, after the agents were developed and they started sending data to the ThinkSpeak channels, and then certain conditions were met, then we were able to see that the following alerts were generated. We received a notification every time the heart rate went beyond a certain range. Then we also put a react whenever the carbon monoxide was supposed to go beyond a certain range, and we received an email every time it did. And then we also set up a react every time the carbon dioxide level in the patient's home went beyond a certain range, and every time it did, we received a message from the ThinkSpeak application. So in this paper, we have proposed an ontology-driven, contextual defeasible reasoning-based multi-agent formalism, which is able to handle inconsistent information in a highly decentralized environment. In order to prove the validity and the correctness of our work, we have developed a simple case study of a smart healthcare system consisting of two different independent domains, which is the smart hospital domain and the smart home domain. We have also shown the prototypical implementation of our system using the ThinkSpeak platform, and we have used IFTTT, Twilio, and MATLAB platforms with the ThinkSpeak platform in order to generate alerts in the form of SMS, notification, and email. In future work, we plan to develop a state-of-the-art mobile application for smartphone users, which would be able to fulfill their specific needs and requirements. Thank you so much for your time and attention, and if there are any other questions, please let me know.
Hello, my name is Hàn Bích Nguyễn Thị from Department of Multimedia, Vinh Nam Radio and Television, Vinh Nam, Viet Nam, with three authors, Hiệp Xuân Quỳnh and Hải Thanh Nguyễn from College of Information and Communication Technology, Cần Thơ University, Cần Thơ, Viet Nam, and Cang Anh Phan from Faculty of Information Technology, Vinh Nam University of Technology Education, Vinh Nam, Viet Nam. Today we are going to show you our study with title Abnormality Bond Detection in X-ray Images Using Convolutional Neural Network. In this study, we present the necessity of doing research in bond X-ray image and propose a method using convolutional neural network architecture to detect abnormality in bond images. Our presentation consists 4 sections: introduction, architecture, experiment, research, and discussion. In introduction, we explain why we choose bond X-ray images for our study. In recent years, a burden and expansion data shot in the field of health and the rapid development of technology have contributed to improving the effectiveness of diagnosis and treatment. Medical images include CT, MRI, and radiography images, which feature faster, cheaper, readily available, and easy to use. Bond X-ray are one of the initial clinical measurements used for doctors to make a diagnosis and detect other abnormality for the different parts of the body. Moreover, musculoskeletal conditions affect more than 1.7 billion people worldwide, and are the second most common cause of serious disability. The treatment for osteoarthritis is long and costly. In visual, the burden of disease by cause in United States 2017, you can see musculoskeletal disorder as the third cause of disease for people. Recent advancement in machine learning and deep learning have become an efficient tool for medical image analysis. For instance, analysis of electronic health record, bone tunnel diagnosis, evaluate bone image, skin cancer detection, or most recently discovered COVID-19. However, both machine learning and deep learning methods are complex and require a lot of expertise, research, and time to train. There create a significant barrier for researchers. In this study, we present a novel method based on convolutional neural network to detect abnormality in musculoskeletal radiograph in images. In our architecture, first we reprocess and normalize data. Because the radiograph are different size, resizing is needed to have an equal image size. The images size the images are resized to 100 and 100 pixels for our model training. Our convolutional neural network in which structure are illustrated in figure. The CNN contains true convolutional layer followed by masked pooling layer and fully connected layer. For more detail, in figure, CNN receive input data that is 100 and 100 pixel size. The first convolution contains 64 filler kernel, the filler itself being 3 and 3 integer matrix. The second convolution contains through hundreds 56 kernel. The mask bundling layer is used to reduce the dimension of generated feature map. We use the mask bundling layer with size of true and true. The output from mask bundling layer will be latent to convert tensor in the multidimensional form to tensor 1D. Our CNN is implemented with Adam of optimizer with a backup size 32 to avoid overfitting. We use early stopping to stop the algorithm before the loss function reaches a value too small. For our experiment, we present three sections: data description, a value matrix, and experimental scenario. We drew on Hummer study in Mura, a dataset for our convolutional neural network model, and then we compare the result obtained with the result of training Hummer study by 169 layer DNS baseline model. Talk about Mura dataset. Mura is a lab dataset upon X-ray collected by Stanford ML Group. Mura dataset was published with 40,561 images from 19,863 studies, include 7 body texture, eyebrow, finger, hand, humerus, forearm, shoulder, and wrist. In each study was labeled as either normal or abnormal by radiologists. The data was separated into two parts, including training set and validation set. Mora is one of the largest public radiographic image datasets in fit for some illustration image of Mora dataset. To evaluate model, we have calculated the training and validation accuracy, training and validation log, cohesion, kappa score, area rock AUC. For a general assessment of classification, the confusion matrix is used to visually illustrate the model. The learning rate is important metric for the model. It controls how quickly the performance is adjusted to the problem. Therefore, we choose for scenario we choose for different model scenarios to compare accuracy by changing the learning rate hyperparameter of optimizer that implement the Adam algorithm. First, we train the model with the default learning rate of 0.001. After that, we in turn reduce the learning rate into 0.0001 and continue reducing for scenario 3 and scenario 4. In addition, we also train the model with epoch tail 50 and 100. For each learning rate, the epoch with higher accuracy will be chosen. We compare accuracy in 4 learning rate scenarios to the highest accuracy to achieve a good performance for our problem. As a result, we get the accuracy of 0.684 in scenario 2 at about 100 for the training model. Our CNN reached the overall 67.30 of training and 68.4 valuation accuracy. The Hummer image was correctly classified 64.5 28 for the abnormal last, and 72.29 for the normal. For the normal last, the training and validation accuracy is visualized in physics. In the case of unbalanced dataset, the rough AUC appears to be a more efficient measure than accuracy to evaluate performance. Our model achieved 0.659 and 0.655 AUC training validation respectively. The AUC is illustrated in Fig. 7, which drew 188 images of evaluation data of hemorrhage. We have shown the training result using confusion matrix. The hemorrhage is correctly classified with 197 images, 90 images correctly related to be abnormal, 50 abnormal images are incorrect related as normal, 107 corrected related images are normal, and 41 normal images are incorrectly related to be abnormal. The result of our model is better than the result of training on hemorrhage study by 100 layer than snake pipeline model. That's a 60%. In table 2, in Fig. 9, Mura model compare performance between three radiologists and model on a coherent capacity. We highlight the result of a Mura model in red and our model in green on hemorrhage study to extract performance. Indication detecting abnormalities in musculoskeletal X-ray has important clinical application. An abnormality detection model can be used to support the radiologist for faster review and approval. Besides the detection of normal musculoskeletal help to save time, treatment, and cost for patients. In this study, we presented an approach to use convolutional neural network to detect abnormality in musculoskeletal radiographs. Due to a limited number of computational resources, we only implemented a shallow CNN architecture for image classification tasks on hemorrhage in Mura dataset. We hope our framework can help to classify musculoskeletal X-ray images to be better and contribute to the development of more diagnostic imaging methods. There are still many other machine learning methods, and more in-depth research is needed for larger sets of images in the future. Thank you for listening to our presentation.
Good day. Thank you for the opportunity to present the work titled Statistical Properties and Modeling of DDoS Attacks. This work that I will present is an ongoing implementation of a design of a DDoS simulation testbed that uses parameter estimation and probability fitting of source IP features of a network. We explored the issue of the lack of adequate and recent evaluation dataset. We therefore designed a way that can be used to generate synthetic data that simulate the DDoS attack. We found that the Gaussian probability distribution best represents the normal operations of a network, while the probability distribution of the Poisson best represents the operation of a network under a DDoS attack. Without going into too much detail of the presentation, let me first start by introducing myself. My name is Pierre Machaka. I'm from the University of South Africa in Johannesburg. I am based at the Science Campus in the Department of Computer Science. My main research interests are in cybersecurity, the Internet of Things, machine learning, and ICT for development. I enjoy teaching and mentoring the youth in science, technology, engineering, and mathematics subjects. As shown by this presentation slide, I also enjoy programming and coding. In my spare time, I enjoy photography, soccer, sports, and long-distance marathon running. The rapid change of information communication technology has made information to become easily available using faster and cheaper means. The use of these technologies has made the move away from traditional desktop computer to the cell phone, and suddenly to the Internet of Things. In the Internet of Things, many of the items that surround us in our homes, shopping malls, and workspaces will be connected to the Internet in one form or another. People's cell phones are connected to their home lights, heating and cooling systems. In some instances, homes are automated to make customers comfortable and enjoy peace of mind. In other instances, a cell phone app is connected to the municipality's bus and train system in order to show routes and location of possible modes of transport services. Other services include those that are provided by banking and insurance industries. These services have now shifted from the traditional banking service being available only at the bank's building branch to those services being available on the mobile app. People can now transact on the cell phone without entering a traditional bank's building. This has made societies to become more dependent and heavily reliant on these technologies, such that a single disruption in these services may directly affect major aspects of the society. These kinds of interruptions can be sharply felt and in some way lasts longer than can be bearable. For example, an interruption in the business organization or government's ICT infrastructure may have a substantial impact on their day-to-day activities. In the example of the bank, if there is a major disruption in their services, banks loses a lot of revenue and consequently have disgruntled customers and therefore tarnishing the business's image. The use of Internet of Things has increased the number of devices that are connected to the Internet at any time, such that hackers are taking advantage of this large size of devices connected to the Internet in order to carry out an attack. They take advantage of the fact that the Internet did not have security in its initial design. Therefore, attackers have taken advantage of this design glitch. Attackers use easily available malicious tools to carry out an attack on the Internet. These attacks have exploited and taken advantage of these devices that are not secured and use these devices as a means to carry out a large-scale attack. This disruption can be the result of a DDoS attack. A DDoS attack is a large-scale variant of the denial of service attack. In DDoS attack environment, the attacker uses a network of compromised machines. These can be bots, zombies, slaves, or agents. Different researchers use different terminologies, but they refer to the same attack agent. These machines are used to attack a single target victim to cause a large-scale denial of service. The compromised machines will be infected with a Trojan or a backdoor program. This will allow the attacker to take control of them and the master bot will instruct all bots to simultaneously and repeatedly flood the target system with a large number of artificial requests. This will eventually cause a large-scale DDoS for the legitimate user and of the target victim system. A recent example is that of the Amazon Web Services, and it has been termed to be one of the largest DDoS attacks in history. In February of 2020, they observed and mitigated a 2.3 terabits per second DDoS attack. In their research, they also indicated that there has been 23% increase in DDoS attacks observed in the first quarter of 2020 compared to the first quarter of 2019. This induced disruptions may be due to a hacker's endeavor to manage damaged services using a denial of service attack. There exist two types of network intrusion detection classifications. That is a signature-based and an anomaly-based detection system. Signature-based systems attempt to define a set of templates or policies that can be used to decide that a network, given a network traffic pattern is that of an intruder. If the attack belongs to a class of attacks listed in the database, then it can be successfully detected and or identified. As a result, signature-based systems are capable of attaining high levels of accuracy and minimal number of false positives in identifying intrusions. However, signature-based detection fails to detect unknown attacks or a variant of the known attack. The limitations of the signature-based intrusion detection were therefore the motivation for developing an anomaly-based detection system. Anomaly-based intrusion detection systems are interested with identifying events that appear to be anomalous with respect to a normal system's behavior. An attack is declared once a deviation from normal traffic behavior is observed. Anomaly-based detection systems has some inherent limitations. Firstly, a sophisticated attacker can monitor the network traffic and train the attack to evade the detection system. And secondly, the difficulty in setting up an optimal threshold leads to an increase in false positive rate. Thirdly, it is very difficult to extract both qualitatively and precisely appropriate features of a legitimate and anomalous network behavior. A large number of DDoS attacks assume constant rate format. From the onset of this type of attack, packets from the attack agent are sent at a stable and persistent rate. The attack agents generate packets without a break or modification in their rate of attack. The impact of such an attack on the victims is quick, continuous, and sudden. These types of attacks are easily detected by signature-based detection methods. Attackers have evolved their attack techniques in order to evade detection, and they have designed low-rate attacks. A low-rate attack strategy gradually increases until all available system resources are exhausted. This strategy obstructs the detection of the attack by slowly degrading the victim's services over an extended period of time. These types of attacks can adjust the attack rate depending on the victim's reaction to the attack. In this form of attack, the victim will experience a periodic service disruption because the attacker will occasionally relieve the attack effects from the victim in order to evade detection. In this research paper, we look into challenges faced by researchers for developing effective detection systems. Some of them being the first issue, dimensionality in traffic features, and secondly, choosing a better statistical probability distribution that is best fitted for modeling traffic data and the use of synthetic data sets due to the lack of good quality data sets. Therefore, in this paper, we attempt to answer the following questions. Firstly, in the literature, researchers have used Features of the source IP address of incoming packets as a beneficial metric for identifying the onset of a DDoS attack. However, high dimensionality in IP address features and the complicated correlation between them causes heavy computational overheads and makes the detection task challenging. Therefore, we ask, how can the onset of a DDoS attack be detected based on a simple feature such as the source IP address? Secondly, existing DDoS attack datasets have limitations. There are legal and privacy issues that accompany sharing of captured datasets. This has therefore led to a lack of real datasets that may be used to model DDoS attacks and to evaluate new DDoS attack detection techniques. Research questions that arise from this challenge are: what are the essential statistical characteristics of a DDoS attack? How can we model a DDoS attack's behavior so that we can synthetically generate realistic DDoS attack traffic data? In this research, we focus on the TCP SYN flooding attack. This type of attack is an example of a network layer flooding attack, and it is one of the most common and powerful flooding methods. It exploits the vulnerabilities of the TCP three-way handshake. This is depicted in the figure. In a normal TCP connection, the client initiates the connection by sending a SYN packet to the server as a way of requesting a connection. Upon receiving the connection request, the server will open a connection session and respond with a SYN acknowledgement packet. By doing this, the server stores details of the requested TCP connection in the memory stack and allocates resources to this open session. The connection remains in a half-open state. To complete the three-way handshake with the server, the client will need to confirm the connection and respond with an acknowledgement packet. The server will then check the memory stack for an existing connection request, and the TCP connection will be moved from SYN received state to an established state. If there is no acknowledgement packet sent within the specified period of time, the connection will time out and therefore releasing the allocated resources. In a TCP SYN flooding attack, the attacker streams large volumes of SYN packets towards the victim server. During the high rate flooding attack, for a period of time, the server will maintain a large volume of incomplete three-way handshakes and allocate resources towards these false connection requests. The server will gather more false requests and eventually exhaust its resources. This will prevent new requests and the legitimate client request from being further processed by the server. For the purpose of modeling attacks traffic data in this research, we analyzed the attack-free data from various sources of IP address in the DARPA dataset. This is a dataset that was collected using actual traffic data from the MIT Lincoln Laboratory. The data contains network traffic trace data taken during a day of network activity. In this experiment, we considered trace data where there were significant traffic activities. We therefore considered trace data between the time 8 in the morning and 7 p.m. And thus, we have an 11-hour of real network packets in the experiment. We filtered the dataset by source IP address and TCP protocol and obtained the TCP SYN. We considered SYN packets as we are investigating the detection of an onset of a TCP SYN DDoS attack. This image in this slide depicts the trace of attack-free data. This is a normal performance of the network under no attack. In the next trace, it shows low intensity attack trace in the simulated data. In this part of the trace, a 50% above normal traffic performance was used. This can be seen between the intervals 20 and intervals 40. In this trace, this is a high-intensity attack trace in the simulated data. In this part of the trace, 250% above normal traffic performance can be seen between the same intervals 20 and interval 40. The implementation and development of the testbed was in MATLAB. To test the efficacy of the testbed, two change point detection algorithms were deployed. We used the cumulative sum and the exponentially weighted moving average algorithms. The implementation details of these algorithms are elaborated as follows. The QSUM and the EWMA belongs to a family of change point detection techniques. These algorithms are based on the hypothesis testing and were developed for independent and identically distributed random variables. In this approach, an abrupt change occurring at any time can be modeled using two hypotheses, theta nil and theta 1. The first hypothesis, theta 1, represents the statistical distribution before the abrupt change had occurred, and theta 2 represents the statistical distribution of the abrupt change after it had occurred. In this experiment, the hypothesis testing the dependence of or the states of network that is in attack mode and in normal mode. These experiments investigated the performance of the QSUM and EWMA algorithms' performance against the DDoS attack, both for low and high intensity attacks. We also investigated the trade-off between the algorithm's detection rate, false alarm rate, and detection delay. For the EWMA simulation results, in the case of high-intensity DDoS attacks, the algorithm was able to detect high-intensity DDoS attacks with a detection accuracy of 100%, while the false positive rate remained at an average of 30%. The experiments further revealed that the detection delay was on average between 11 and 23 seconds. Therefore, the algorithm was able to detect with accuracy the high rate attacks for 11 to 23 seconds after its onset. In the case of low intensity attacks, the EWMA algorithm was able to detect attacks with 100% accuracy. However, the false positive rate increased between 40% and 60%. The EWMA algorithm was able to accurately detect a low intensity attack on average 40 seconds from its onset. For the QSUM algorithm simulation experiments, and for the case of high-intensity DDoS attacks, the algorithm was able to detect high-intensity DDoS attacks with 100% detection rate, while having a false positive rate of between 0 and 7%. The QSUM algorithm had accurately detected high-intensity DDoS attacks on average between 26 seconds to 45 seconds from its onset. For the case of low-intensity DDoS attacks, the QSUM algorithm yielded a detection rate between 14 and 81%, while maintaining a low false positive rate between 0% and 7%. Even though the QSUM algorithm could not reach 100% detection rate, the fastest detection delay was recorded as 73 seconds detection delay from the onset of an attack. The results of the simulation testbed had shown that the algorithm was able to accurately detect high-intensity attacks, while it is fairly reasonable with a false positive rate and detection delays. However, these algorithms have drawbacks when a low-intensity DDoS attack presents itself in the network. This further indicates that there is room for improvement in terms of accurately detecting the cunning techniques of a low-intensity DDoS attacks. The work presented in this paper is an implementation of a design of a DDoS simulation testbed that uses parameter estimation and probability fitting of source IP address features of a network. We explored the issue of lack of adequate and recent evaluation datasets. We therefore designed a way that can be used to generate synthetic data that simulates a DDoS attack. We found that the Gaussian probability distribution best represents the normal operation of a network, while the Poisson probability distribution represents the operation of a network under a DDoS attack. Researchers have often used a source IP address in combination with other network traffic features to design a DDoS attack detection algorithm. However, this has often led to issues of high dimensionality in data. In these experiments, we used source IP address only to find out if a single network traffic feature can be used for detection of DDoS attacks. We used various scenarios of network attacks where we considered high-intensity attacks and low-intensity attacks. To further evaluate this testbed, we developed two change point detection algorithms, namely the EWMA and the QSUM algorithm. The deployment yielded positive results and also indicated areas of improvement. We plan to further intend to implement a deep learning algorithm on this testbed for further evaluation with more complex and recent detection algorithms so that we can learn more about the efficacy of this testbed for future use. I have come to the end of my presentation, and you are more than welcome to make contact with me via Twitter at the Twitter handle presented, and you may make contact with me on the email on the slides. Thank you so much for your attention, and I will be taking questions from the participants. Thank you.
Hello everyone, my name is Long from Ho Chi Minh City University of Technology. First and foremost, I hope you and your family are safe and healthy during the outbreak of the coronavirus. In this video, I will present our research work, which is submitted by ICCASA 2020, titled Estimating Land Surface Temperature and Emissivity in Ho Chi Minh City using remote sensing image. And this is the table of content which outlines all the sections of my presentation. Firstly, I will give you an introduction of our paper by presenting problem statement, objectives, and contributions of this paper. And then I will introduce an overview about the geographical area and remote sensing data source, which we will choose to investigate in this study, and present our methodology to retrieve land surface temperature from satellite imagery. In the third session, I will talk about a cloud computing-based system used to handle and process satellite images to deal with environmental issues in Ho Chi Minh City. The experiment and evaluation will be delivered in session 4, and finally is the conclusion and future work of our research. Now, I will move to the first session, the introduction. You know, nowadays, urbanization processes are growing continuously and rapidly. Even though urbanization brings many benefits for economic and cultural development, it generates many social problems, especially in environment. For instance, as you can see in the diagram, rapid urbanization can cause some environmental issues like significantly shrinking of green space, introducing many types of pollution, increasing urban heat, and enhancing global warming. Those problems are the main reason leading the escalation of human land temperature, bringing negative impacts on our short or long-term health. So, it is necessary to develop a modern system to automatically monitor surface temperatures of human land, and thereby providing a hazard map to detect and prevent environmental issues. Fortunately, remote sensing has become increasingly important in many research fields, especially in environment. Using satellite remote sensing is one of the most cost-effective and efficient approaches to monitor physical characteristics of environment. And in this paper, we will study on how to use remote sensing image to estimate the land surface temperature of Ho Chi Minh City, the biggest city in Viet Nam, and propose an automated system to process those images. The objectives and contributions of our research work is presented in this slide. We will focus on employing Landsat A image, which is collected by the latest Landsat satellite launched by the National Aeronautics and Space Administration and the United States Geological Survey, to estimating land surface temperature for Ho Chi Minh City, the urbanized city in Vietnam. Our contributions in this paper include a methodology to retrieve land surface temperature using satellite imagery, a cloud-based solution for automatically processing Landsat A datasets, and a hazard map system to monitor environmental parameters in Ho Chi Minh City. Let's move to the next session. In this session, I will outline the geographical specifications of the study area, the satellite datasets, and our methodology using remote sensing images to estimate the land surface temperature. As I presented in the title of the paper, the study area we choose to investigate is Ho Chi Minh City, which is one of the biggest cities in Vietnam. As you can see in the picture, the city is located in the south of Vietnam and close by Bình Dương, Tây Ninh, Đồng Nai, Bà Rịa Vũng Tàu, Tiền Giang, and Long An. The total area of Ho Chi Minh City is about 2,100 square kilometers, including 90 urban and 5 rural districts. And the population is nearly 8.6 million people. So, the city is quite densely populated. Regarding the weather, Ho Chi Minh City has a tropical wet and dry climate with two main seasons, including the rainy and the dry season. The average humidity is about 75%, while that of temperature is about 28 degrees Celsius, with little variation throughout the years. Regarding satellite datasets, we choose Landsat 8 to process it. Landsat 8 is a program of global space imagery acquisition. The key mission of this satellite is to collect multispectral imagery in medium spatial resolution, thereby distributing for public users to bring benefits for many sectors such as agriculture, science, government, environment, and so much more. The Landsat 8 satellite remote sensing data is acquired from two sensors, including the operational land imager and the thermal infrared sensor, while the operational land imager provides 9 bands with 30 meters spatial resolution, and the thermal one provides 2 bands with 100 meters spatial resolution. With Landsat 8 image, we can process and observe some environmental parameters such as heat, moisture, surface temperature within the defined areas. And here is the specification list of all bands in a Landsat 8 dataset. To cover the whole Ho Chi Minh City, we need to collect 3 Landsat 8 skins at the path row locations of 125.52, 125.53, and 124.53. To retrieve land surface temperature from Landsat 8 image, we have some steps as described in this flow diagram. We will divide a Landsat 8 dataset into 2 subsets. These are the operational land imagers and the thermal infrared sensors, and separately process each subset to get values of the dependent factors of land surface temperature. To process Landsat 8 thermal infrared sensor image, these are the band 10 and band 11 in the dataset. We first convert the digital number to the top of atmospheric spatial radiance. Typically, the standard product pixel values of Landsat 8 data are represented in 16-bit unsigned integer format. So we need to convert those values to the TOA spatial radiance or reflectance to quantify and calibrate for high accuracy in processing. And then we convert the TOA spatial radiance to the brightness temperatures by using this formula. This is a very important parameter in calculating land surface temperatures. Next, we will process the Landsat 8 operational land imager image, which are the images from band 1 to 9. Similarly to the thermal infrared sensor image, we first have to convert the digital number to the TOA spatial reflectance by using this formula. Then we need to correct for the sun angle of the TOA reflectance. After we got the land surface reflectance values, we will continue to calculate the normalized different vegetation index. This is the NDVI value. The value is used to evaluate the density of vegetation on land surface by observing the visible and the near-infrared solar radiant reflectance. Those values can be get in the metadata files. This is the value of the band 5 and band 4 image in the Landsat A dataset. The NVDA then will be used to calculate the vegetation proportion. This is the fraction of green vegetation in each pixel of the Landsat A image. After that, we will use the vegetation proportion to calculate a very important value called land surface emissivity. This is the key factor for the accuracy of the land surface temperature estimation process. At final stage, the land surface temperature values will be retrieved using the equation 8 in this slide. From this equation, we can see the land surface temperatures is depending on the brightness temperature values that we calculate in the operational land imager and the land surface emissivity as we calculate in the above step. Based on the satellite datasets and the derivation of land surface temperature methodology, we developed a cloud-based system for automatically processing and estimating the land surface temperatures and emissivity in Ho Chi Minh City. And here is the overall architecture of our cloud system. In this system, we will apply some state-of-the-art IT technologies to bring intuitive and visuality for monitoring environmental issues in Ho Chi Minh City. The system consists of 3 main modules. The first module is the Satellite Imagery Provider module. This module is used to provide remote sensing data, such as Landsat A datasets for the cloud server. Those datasets are freely available to find and download in some popular websites like the Earth Explorer or the Earth Data. The second module is the Image Processing Cloud Server. This module provides the ability to automatically search and download up-to-date imagery data from the providers, in associated with fast and reliable data processing in retrieving land surface temperatures and other parameters of the satellite image. The third module is the Client Application. This module provides a variety of user-friendly applications. It can be worked on many cross-platforms such as computer, laptop, or smart device. And here is an overview of the class diagram of our implementations. Now I will present some experiment results and evaluations of our methodologies and system. We did the experiments with 2 area samples. The sample A is a skin of a road in Ho Chi Minh City, and the sample B is a skin of the grass field in Ho Chi Minh City. And here is the coordinate location of each sample. With each sample, we measure the land surface temperature with the 30-second interval in a range of about 30 minutes. And the results of the land surface temperature value is shown in this table. As you can see in this table, the land surface temperature values of the sample A is higher than the sample B. At the end, we will give a conclusion of our research work. In this study, we present our approach to estimate the land surface temperature and emissivity of Ho Chi Minh City using the Landsat A satellite image. We developed a cloud-based service to automatically download and process data. The experiment results show that our system has some good results, but need to evaluate more samples with various survey conditions. Last but importantly, we acknowledge the Department of Science and Technology of Ho Chi Minh City for funding this research. Thank you for your listen. Please feel free to send us emails to discuss if you have any questions. Thank you very much.
Hi everyone, welcome to ICCASA Conference. My name is Vinh from Ho Chi Minh City University of Technology. Today I will introduce about a comparison between stack Auto-Encoder and deep learning network in river runner prediction. So this is outline of my presentation. It includes 5 parts. The first, introduction. The second is about background. In this section, I will introduce about background of deep learning network and stack Auto-Encoder. The next are two model architecture for runner prediction, and now research experimental evaluation, and finally is a conclusion. Let's go to introduction session. Recently, artificial intelligence is extremely developed. Contributing to that development is the big data, including time series data. Among several methods used to forecast hierarchical time series such as rainfall, reservoir inflow, and river runoff. Besides, artificial neural network, also called INN, has been applied to commonly. But the prediction accuracy of INN is still limited. As for river runner prediction, deep learning network, also called DBN, and stack Auto-Encoder, also called SIE, are two kinds of deep neural network which are commonly used. In this study, we aim to compare the recent performance of SIE model with that of DBN model on runoff data of stream of river in Central Highland in Viet Nam. Next, in this session, I will talk about background of two models, deep learning network and stack Auto-Encoder. About deep learning network is based on stacking restricted Boltzmann machine, also called IBM. The IBM is kind of stochastic artificial neural network with two connected layers, a layer of binary visible unit and a layer of binary hidden unit. So the hidden unit acts as latent variable that allow the IBM to model probability distribution over state vector. You can see on figure 1. And the hidden units are conditionally independent given visible unit. An energy by model of RBN can be trained by performing gradient descent on log likelihoods of training data with respect to the RBN parameter. The estimation of the gradient can be done by contrastive diversion algorithm. The next, I will talk about stack Auto-Encoder. Stack Auto-Encoder is formed by stacking Auto-Encoder to make deep neural network. The structure of Auto-Encoder is shown in the right on the figure 2. You can see in here. Which each Auto-Encoder has two basic components that are encoder and decoder. The first layer is an encoder which is simply a kind of fully connected or convolution layer. It is taking the inputs and compressing it into smaller representation with smaller size. The smaller representation of input is called the bottleneck. The bottleneck in here. In here, knowledge or feature from the input will be compressed and retrain important feature and used to pass through the decoder. Second, decoder also has same architecture as the encoder, but the difference is that it takes the knowledge from the bottleneck then try to reconstruct by input by using fully connected or convolution layer. Let's talk about stack Auto-Encoder is formed by stacking Auto-Encoder to make a deep neural network, where each Auto-Encoder is independently trained and the output of is hidden layer of Auto-Encoder connected to the input of the next hidden layer. This is visualization of stack Auto-Encoder model, which includes 3 Auto-Encoder. As you can see, it consists of 3 Auto-Encoder: Auto-Encoder 1, Auto-Encoder 2, and Auto-Encoder 3. And their Auto-Encoder are trained independently of each other from hidden layer and that are stacked them together. The question comes here: how do we train the stack Auto-Encoder neural network? Stack Auto-Encoder training divided into 2 parts. The first, the hidden layer, which is taken from Auto-Encoder. They are trained by unsupervised algorithm and then refined by supervised methods. Stack Auto-Encoder network is trained as follows in here. The first, train the first Auto-Encoder with input data and return the feature vector in here. As you can see in the visualization here, we train independently Auto-Encoder 1 and Auto-Encoder 2 and Auto-Encoder 3. So use the output of last layer as input for reduction layer in here. And after all the hidden layer have been trained, the backpropagation algorithm is used to minimize the confusion and update the while with training set label to achieve fine-tuning in the supervised way. So the next, I will introduce 2 model architecture for run-up prediction. This is basically architecture of deep belief network and stack Auto-Encoder model that we experiment. So on the left is the deep belief network architecture. It is consists of 2 RBM and 1 multi-layer perceptron, also called MLB. But in general, we can add some RBM into the deep belief network model to make the model deeper. On the right in here, it is stack Auto-Encoder, which is built by stacking 3 Auto-Encoder together in order to extract meaningful features from data. So in order to reset the run-up data before entering deep learning model, we use sliding window technique from time series data is in here. It will be converted into the new data Y in here, and then we apply the new data Y to release the model. So we will use 3 measurements for evaluation. That's root mean square, also called RMSE, and coefficient of correlation, also called R, and mean absolute recentic error, also called MAPE, to evaluation of result from model region. Next, I will talk about the result of our experiment. For this work, Strand Box River in Viet Nam had been selected as study region. So the run-up data are collected from Khao 14 and Buôn Hồ and Đức Xuyên measurement station. As you can see in figure, in here, HD study data includes Khao 14 and Buôn Hồ and Đức Xuyên measurement station. The data will be divided into training set and testing set. We normalize value to run between 0 and 1. And Keras framework used to implement deep learning model. And this is the configuration of my computer for experiment. Next is the parameter setting. We will build deep learning network model. Based on the best hyperparameter select for the deep network regression model, rebound in the previous work by 3S on. In the sum, the good deep network model considers 4 hidden layers and 5 neuron per layer. As for stack autoencoder through experiment, we select 3 autoencoder for the number of autoencoder layers, and the number of hidden layers not for stack autoencoder are 200 and 400 and 200. So this is comparison research for 2 models from 3 run-up dataset on Sandbox River. You can see research in the table. The value in the box are the best value on the matrix when comparing 2 models. As you can see, most of research of stack autoencoder model are better than research of deep network. You can see here, here, and here. And about time of training and testing process. So research showing the table from experiment research. We know the training time and testing time of stack autoencoder is slightly shorter than deep network. So you can see research in the table. Finally, conclusion session. In this work, we compare two deep neural network model, includes stack autoencoder and deep network in river application. So experimental research show that stack autoencoder bring out better resistance accuracy than deep network on 3 random dataset from Siricharoen River. So the result simply that stack autoencoder is promising deep learning approach for random time series forecasting. In the future work, we will combine stack autoencoder with chaos theory in order to improve future river random prediction. And combining stack autoencoder with long short-term memory, also called LSTM network, in order to improve the future river prediction. So this is my presentation. Thank you for your attention.
Hi everyone, please I would like to introduce myself. My name is Phan. I'm come from Ho Chi Minh City, Viet Nam. I am a lecturer and co-cast faculty of Information Technology, Nguyễn Tất Thành University, Ho Chi Minh City, Viet Nam. Today, I am to present on my work here in the conference. Thank you, the organizing committee, for giving me an opportunity to present my data here in the conference. I am going to talk today about my topic, developing data model managing resident by space and time in three-dimensional geographic space. In the next slide, I will show content. My presentation is divided into the main section. Section 1, Introduction. Section 2, Objective. Section 3, Overview of the data model. Section 4, Developing Spatial Temporal Residential Data Model. Section 5, Experiment Research. Section 6, Conclusion and Development. Finally, References. In the next slide, I will show introduction. The increase in population by geographic location will always lead to society with a strong development in both quality and quantity, in addition to policy and negative issues. In community, lead to archive with store of the paper and book exceedingly expanding, recognizing the importance and necessity of managing the population according to geographic location and time is to manage the people living, working in territory, and require necessary computerizing the task of residential management, human management to provide timely to labor government, making decision and timely supporting information, the task, security protection, and social order and safety in the territory. Therefore, we need to focus on building three-dimensional geosystem for residential data management. To build this system adapt to own criteria than modeling data model is extremely important and urgent to serve a labor of government or construction and constructor in tracing history, block relation, social relation, period condition relation, period absence relation, and historical orders relation. We can see picture 1. A relationship represented consists of pupil, spatial, temporal, residential relation. Picture 3. A relationship representation space, pupil, and time. In the next slide, I will show introduction. We have 3 problems to solve. Problem 1. Problem 1, I introduce problem 1. We can see a picture below that is an instance about social relationships space, including building position and building shape, time, and pupil participant. Problem 2. We can see a picture an instance including relationship with how holder space in how position and how shape and pupil. House, pupil, permanent population, and the householder. Heads of householder, geographic location. Problem 3, finding and displaying and descendant. A person live have a citizen identify number, for example 11, and name of Vinh. Information display include descendant and of a personally and generalization. In the next slide, I will show object. The paper proposed to develop a SGRDM model to manage relationship and genealogy by geographic location and over time. The new data model is capable of managing human activity as play resident, as workplace, and as location, spatial, and temporal relationship. Class we can see model SGRDM model class spatial, combine class temporal, combine class residential into SGRDM model to manage relationship and geology by geographic location over time. In this last slide, I will show over the data model. The data model based on boundary representation methods. The data model proposed by author from the past to present have applied BREF method, which includes the data model based on vector element represent over 3D array model, represent over object model. The data model based on the three-dimensional block composites methods represent over 3H3 models. Comment and recommendation for the data model. To represent spatial features include residential house, building, villa, apartment in a three-dimensional space. Applying modeling is the key to success. The criteria to consider model are the model must be able to represent spatial objects in three-dimensional space and must be able, based on the criteria, outer surface, inner surface, represent level of detail, but also have the ability to store spatial data, store temporal data, store semantic data, and store residential data. Through systemization and classification of the data model have given a clear view the development data model proposed by author. We found that the model many new BREF methods. This method represents three-dimensional object based on predefined elements, include a point, line, surface, frame, body, and this method is suitable for representing three-dimensional object of normal set. From here, this paper proposed to build SGRDM model to manage population data include relationship management, permanent population, temporal population, and search for ancestor and descendant. In the next slide, I will show proposing spatial temporal residential data class data model. Temporal data class, temporal data class, residential data class, residential data record relationship, permanent population, temporary population, stay population, and other basic human information. Therefore, residential class plays a very important role in organizing the storage classes of residential data. Residential data class were built to answer questions related to human activity. the play residential, at the workplace, at the play of living, at the play happening, social relationship. Okay, we can see picture 1. A relationship represent concept of pupil, spatial, temporal, residential. Similar to we can see picture 2. A relationship representation space, pupil, and time. Spatial data class. Spatial data class records shape, style, location, and object in space. The spatial class an important task in residential data management system. Nowadays, spatial position play spatial objects that are understood by human in 2 aspects. Aspect 1, the coordinate of the spatial object located in 3-dimensional domain. Aspect 2, address or attached to spatial objects, including house, building, apartment, place. Combine spatial, temporal, and residential data class to build new data model. Through about analysis, paper combines spatial data class, temporal data class, and residential data class to be in SGRDM model. We can see picture 3. The SGRDM model manages residential data in 3-dimensional geographic space. Class space, spatial class, residential class, temporal class. The new data model is capable of storing, managing 3-dimensional space objects such as building, apartment, round, house. In addition to this data model also has ability to query by time, to query by resident, to query space by time, to find ancestor and to find descendant, to trace history human relationship. We can see the picture 3. Develop propose query in residential data management. Query 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Apply in query 4. Citizen identification number 10, 11. The person name rings. Apply recursive query and output data. Based on the picture 4, the grouping of family tree include ancestor and descendant image. Similar to apply in query 5. Citizen include input data. Apply in query 5. Citizen identification number 53, person name course. Apply in recursive queries, output data. Experiment result. The paper had detailed the spatial class, temporal data class, residential data class. Combine the 3 class together to build SGRDM model. The paper use Oracle database management system to install SGRDM. Using Oracle spatial data type to store spatial data. It's then combined with Sita programming to visually represent some form with typical queries. The paper select presenting 5 visual form through file query. Okay. Each from user must provide input and output parameter. Experiment from 1. Apply query 5. Apply query 1. Input and output. Okay. Results. We can see picture 5. Space building, participant, social relation, geographic location. We can see view A and view B. Experiment from choose, applying query to input or output. We can see space, house, Thai data type, period, absences relation, drugs use, geographic location, participant. From trees, apply query trees, input, output. How on the with identification number of full name, information display include how on the space, how on the permanent population or how on the from for apply query files in input student identify number output and set the person label name code or in. We can see picture 10 and picture 11. From file apply query for input and output result. Conclusion. This paper was presented as follows. Present an overview of the spatial temporal data model and then give us some comment and suggestion. Present detailed construction of the spatial data class, temporal data class, residual data class. Then combine the three classes into Hertzian model. This model shows its viability and open up new direction in supporting the method storing residential data over time and space. This model is not only capable of query relationship, query in permanent and temporal population, query in space, and query process chain basic human information over time, but also have ability to find ancestor and descendant. Illustration resource from whole research derived from above query. In query, there are instant, point of time, period of time, and semantic description residual data. Development, in addition to the data model, can also develop and expand semantic inheritance classes for both space and residential, and other classes such as color, pattern, style for spatial objects which are building in three-dimensional geographic, intending to share over extended storage purpose without affecting structure of the model. Finally, references. Acknowledgement. I'm thankful to the Faculty of Information Technology, Department Science and Technology, and especially I am very thankful to Director Bao Nguyễn Trắc Thành University for assistance to free for me completely creating this paper. Thank you so much. Thank you for your attention.
Hi everyone, today I would like to present our papers, which names trigger to be a tool generating event-based models from database triggers. My name is Anh from Hanoi University of Mining and Geology. Okay, so my presentation today consists of 5 parts. The first one is introduction. The second one, I give you a background about the data triggers, about event-based and routing platform. The third one is formalizing triggers. The fourth one is trigger to be tools, and finally, I will give some conclusions about these presentations. Okay, so first, the introduction. What about the problems? The triggers image of a block code, which is human readable and without any formal semantics. Actually, we can only verify if a trigger terminates or conflicts to integrity after executing it or with human inspect step by step. That means you only know that a trigger is correct or not after they execute it. The formal methods, which are complement to testing techniques, use the mathematics proof to verify the system behavior correctness, but they are complex and hard to use in the development. Okay, so about the related work. In this presentation, I introduce from several point of view. The first one about from the theoretical aspect with our support tool. There are several approaches introduced to check the correctness of the triggers and also perform the dynamics analysis to check the active rules at runtime to see if the state of database is repeated. Another approach is with support tool using model checking techniques, for instance using spin, cache objects. The user can use this to model the system and verify the system correctness, but the user have to model the system manually. So our approach is different. First one, we describe a database system in event-based formal method. Then we can show if a trigger's execution is correct at the desired time. This is help us to realize that if the triggers contains errors at earlier phase. The property of the system can be automatically proved through the proof application generated from the routing platform. We also introduce a trigger to be with partly support for auto translation from the database system to event-based model. Okay, so these slides I give you some background on the triggers and event-based. The first one is triggers, and the second is event-based. What is event-based and event-based structures? Database triggers. Database triggers, as I mentioned in the first slides, the database triggers is a block code that is automatically fired in response to a defined event in the database. The structures of a trigger is follow EAC structures. That we have here a roof name, we have if condition, then do the action. There are classified in two types of triggers, the DML triggers and DDL triggers. So event-based is a formal method for system level modeling and analysis, and this is the evolution of the event-based method and is more suitable for develop large reactive and distributed system. The support tool have been provided for the event-based specifications and proof in the routing platform. In this slide, you can see the simple structures of an event-based model. It consists of two components, which are MerSIM and context. The MerSIM is dynamic part, while the context is the static part. The MerSIM can see the context, and you can see in the MerSIM there are several concepts in the MerSIM and in the context. We can list here some very principal concepts of the event-based. The first one is the variables. Variables represent the state variable of the specification model. Invariance, described by the first-order logic expressions, the property of attributes defined in variable clauses. Invariant need to be preserved by even B clauses. Two other concepts are theorem and events. Theorems define a set of logical expressions that can be deducted from the invariance. Events define all the events that occur in a given model. Each event is characterized by its class. And this is the event building platform. Using this platform, you can model projects in event B, you can describe the event B, and can prove the system in event B notation. So we move to the next part, which are the main idea of the paper. The first one is how we can formalize the DML triggers using event B. This slide we present our approach from the database system. We model it in event B models, and then we use the routing platform to verify the system routing. How to model a database system? The first one is define some definition about the database system. We can define a database system by a tree tool like this, and also we can define the triggers like in the definition in definition tool. Then the triggers also is presented by tree tool like G, C, E, A. So now we consider how we can translate the database system to event B. We have here applications. We use a DML statement to query or to update, to insert in the data in the table. We also use a DML triggers. From this model, we translate the table into the event B set. We also translate the DML trigger to event B various variables, invariant, and event B triggers. So we present transformation rules. We have here 3 rules to translate a database, a table, and the triggers into event B. We formalize these triggers based on the similar structure between the triggers and between the ECA rules and event B model. And we can have here, we can translate in the right part is the event of the event B model. In the left part we have the ECA rule, and we translate directly from the ECA rule to the event B event. In this slide we translate directly each DML statement into the body of the event B event. Okay, so after modeling, how we can verify the properties? We can verify the termination, or we can verify the content preservations using event B event. We can verify the deadlock property, and we also can be using the invariant proof application rules. In order to help the engineer to have the model, event B model easily, we present and implemented a tool trigger to B, and this is the architecture of the tool. It consists of several parts like UI database adapters. We also use the trigger template and RTLR as SQL extractor and translator. In order to translate a database database system to even be, we follow the workflow. The first one is browse the database, we connect it to the database and parse the SQL structures and also extract the database model. After that, we translate the SQL model into EVMB model. And finally, we write down the EVMB model into routing project file system. Okay, so in order to illustrate the tool and the approach, we present a very simple example about the human resource management. We have a database system, have constraints, and we also have a triggers, 2 triggers. Okay, so we run the tool with the small example, and we have the first images is about the path trees from the database system, and we have the routing project. You have a routing projects file system automatically generated when we're using the tool. And this image is the projects that imported into the routing, and you can see here the triggers is created automatically, and we also can prove the system correctness using the proof applications. So we can verify the triggers using the rules that we already proposed in the previous slides. If you can prove the termination, you can prove the constraint preservations. Okay, so finally, we already proposed an approach to formalize and verify the database system with the constraints and the triggers using EVMB. The proposed trigger to be tuned accept the DBMS and automatically generated EVMB model and the corresponding routing projects. The database developer do not need much skill and do not have to spend time in detail modeling with EVMB. However, the tool is need to be improved with more complex cases and more DBMS and integrated with the root as a routing blockchain. Okay, so this is my presentation, and thank you for attention.
Good day, my name is Tung. Today I would like to present about my paper predicting the level of hypertension using machine learning. First, in my introduction, as you might know, data mining now is very popular. It's also possible to analyze data from huge amount of data of patient and from hospital every day, and it can support many doctors in process, diagnosis and examination and treatment of disease for patient. The problem here is whether we can accurately diagnose the patient disease based on the information provided. The information may be age, gender, occupation, symptom, that information, and from which it very important to achieve accurate diagnosis to minimize the work pressure for the doctor. We have chosen hypertension to test this problem because in the future hypertension will be very popular because of the aging of the population. Input data will be the information of patient related to hypertension, and the output information is a result of predicting the level of hypertension based on the information given. There are numerous factors which can cause hypertension. For example, the aging play an important role, and the older the people, the higher risk they have for hypertension. Gender is another cause of high blood pressure. In addition, secondary hypertension is also the consequence of several conditions like kidney disease, thyroid disease, adenoma, neurological disease such as mental disorder, diabetes, and other disease. Moreover, hypertension is also the result from unhealthy lifestyle. For example, overweight and obesity increase the risk of hypertension. Obesity is when people's body exceeds their body weight. For example, BMI in men is more than 25. Women are over 30. Other factors include lifestyle, unhealthy distancing, too salty eating. The amount of salt exceeds 5 grams per day. Too much alcohol drinking, smoking also cause hypertension. There are numerous factors which can cause hypertension. Research have proved that early symptoms of hypertension can be recognized by some related tests such as blood biochemical test, blood uric, creatine, electrolyte, to determine diagnosis of kidney-related disease. Other tests include blood glucose test, which relate to diabetes, which evaluate blood lipid disorder, cholesterol, triglyceride, HDLC, LDLC. Also help monitor and detect some disease such as blood lipid hypertension. There are more and more research related to diagnose patients from medical record received. The algorithm used to specify for classification problems such as nearby association rule, KNN decision tree. Specifically, this problem information about patient will play an important role in classification. So we will have to consider information need to classification. We have machine learning training process to diagnose test described in the figure below. First, it includes data, and after that, feature, filter, chaining data, chaining, and the model. Data is the original data set of DZ, including multiple data streams with many information about patient. Feature, filter, process of filtering and retrieving feature from data. Only the feature are needed will be retained for later chaining. Chaining data is a data set for chaining after remove unnecessary feature in original data set. Chaining in the chaining process based on chaining data set using machine learning algorithms such as SVM, nearby model EAI retain information chaining result after using machine learning algorithm on the data set defined to predict the future result. It is a flow diagram for the process. All the data for the paper is collected from medical record for hypertension from Sơn La Province Hospital in national project, application and deployment of software system for integrating and connecting biomedical electronic device to support monitoring of health and epidemiology in Northwest region. Initial data for the test is a set of statistical data for hypertension collected by the author from the hospital. Data was collected, processed, and stored in the Excel file table. Each line contains information for each person. Each column represents information about that patient, such as birth rate, province, district, information about patient health status at admission. This is a screenshot of the data. The data for hypertension include around 2,600 patients, from which around 1,900 are labeled. It has been classified by a World Health Organization. There are 3 types of hypertension patients that we use as classification label for hypertension dataset. Hypertension level 1, hypertension level 2, and hypertension level 3, which the quantity for level 1 is 700, quantity for level 2 is around 660, and quantity for level 3 is 336. After having input data of hypertension, we filter chaining dataset to test the diagnosis of this hypertension. We will build the data in SVM line form, with each line correspond to one line in the original data. The line will contain number representing the feature of the data. For example, with the third feature of value 2, we will represent 3 divided by 2. If the feature has a value of 0, we will not represent it. For feature with numerical value, we will take the numerical value for the feature. We conduct the test using a machine learning algorithm SVM, nearby, decision tree, and KNN. The tool used to support EAI, a machine learning software developed by a university in New Zealand. We running the test. We use 2 models. One model use feature which amount bigger than 70%, and a model with another model with data amount bigger than 50%. That one performs the feature with the data amount bigger than 70%, and it's the simulation result we obtain. That to perform which feature with the data amount bigger than 50%, and we have result in the following table. So based on result, the decision tree always gives a higher result with the accuracy of 83% for the hypertension in both models. Using more feature, even higher result. SVM algorithm also gave quite good result with the accuracy of around 80%. The remaining two algorithms nearby and KNN gives accuracy of about 70%. Conclusion. In this paper, we explore and analyze data on hypertension using machine learning method with the test support tool from Weka. Based on the result of this test, we can more or less access the ability to predict the hypertension using information obtained from the patient, helping support the doctor in the process of medical examination and treatment. In the future, we can continue to test with more accurate and complete data set in order to improve the accuracy of disease prediction. I would like to thank you for listening.
Hi everyone, hope you are doing fine. This is Mahmoudul from the University of Auckland, and it's my pleasure to present our work at the ICCASA. So I'd like to thank the organizers of ICCASA for giving us the opportunity to present our work. So the title of our work is Can Blockchain Fly the Silver Fern? Exploring the opportunity in New Zealand's primary industries. So before I start presenting, I would like to thank Johnny for involving me in this interesting project. Right, as you can see there from the title, that we wanted to explore the available opportunities of blockchain in New Zealand's primary industries. But why did we choose primary industries of New Zealand? Because the primary industries are comprises of multiple sectors such as agriculture, forestry, horticulture, seafood, meat, meat and wool. So the primary industries play a vital role to drive the economic growth in New Zealand and contribute more than 70% of all merchandise exports. And the exports revenue from these industries is forecast to reach 46.5 billion for the year ending June 2020. And this is over 0.5% higher than the previous year. So based on this data, we can essentially see the potential of the technologies in New Zealand primary industries. But there are some common pitfalls, some known impediments in primary industries. Currently, the primary industries of New Zealand are facing two major challenges. One of them is food fraud. The other one is the foodborne illness, which pose significant risk to the safety of the goods and the reputation of New Zealand. If we look at the global data, food fraud is estimated to cost the global food industry 49 billion US dollar a year. And the Ministry of Primary Industries of New Zealand also estimate that New Zealand to have 200,000 cases of foodborne illness per year. And as we all know that the world is experiencing a global pandemic of COVID-19, so we can safely assume that the consumers will demand more accuracy and transparency of information from their suppliers. And that could potentially reduce some of the problems that the primary industries are facing. But the traditional way of tracking and tracing good qualities, such as recording, verifying, securing, and distributing data like provenance of ingredients, freshness, and safety information, it's a costly and time-consuming process. That's why some suppliers around the world have started to experiment and adopt various blockchain solutions to tackle these challenges. So what is blockchain? A blockchain is basically a record of transaction built upon distributed ledger technologies, which is secure, imputable, anonymized, as well as decentralized. And we believe that blockchain can overcome these impediments by promoting radical transparency and renewed trust through digital traceability, as well as blockchain can help to eliminate the need for intermediaries, which could massively reduce transaction cost. Unfortunately, the full market potential of blockchain technology, specifically in New Zealand, is yet to be realized. And currently, the number of blockchain-enabled products and services available in New Zealand rather limited. We know that there are many technology service providers who might be interested to launch blockchain-enabled services, but that would be risky for them if they do not understand their potential market first. So that's why we believe that the understanding of market potential of blockchain is critical to draw interest from technology service providers. So in order to shed some lights on this issue, what we did, we basically reviewed some of the secondary sources, such as industry reports, research paper, and news articles to understand the opportunities and challenges in New Zealand primary industries. And then we employed a market sizing technique known as total addressable market to explore the economic opportunity of blockchain-enabled services in New Zealand. Right, so based on our secondary reviews of the reports, news articles, we have identified several opportunities and as well as challenges that the primary industries of New Zealand is facing currently. Now let's look at some of the opportunities. And as an exporting nation of meat, dairy, agri-food, and seafood products, we believe that blockchain-enabled services in New Zealand could boost transparency, ensure good safety, minimize the risk of errors, and reduce potential fraud. And as a result of this increased transparency, some customer behavior towards product consumption could be improved. So people could follow more healthy diet. And in New Zealand, there are many non-branded, high-quality, homogeneous product sellers. And what they do, they basically sell their product through intermediaries, or you can say third parties, and that actually involves a lot of cost, right? And if they can use blockchain-enabled services, we believe that they do not need any intermediaries, and that will benefit them, and they will be able to make more profit. And New Zealand is one of the very few nations that export chilled lamb, right? So we believe that blockchain can also, but sometimes, in order to maintain the freshness and quality of this sort of product, such as chilled lamb, it is essential. But the traditional way to verify the product, and it's very time consuming, and sometimes most of the times there are very strict deadlines, and which could cause the freshness of the product. So, and we believe that blockchain-enabled services can reduce the time and cost in product verification. That is currently very manual, and it takes a lot of time. And it could also expedite the shipping deadlines without sacrificing the freshness and quality of the product. So as you can see from these findings, we can fairly assume that there are opportunities for different sectors involved in primary industries that can be achieved by enabling or by adopting blockchain-based services. But there are some challenges as well. The primary industries generate a large volume of data from multiple stakeholders. And as we know, that the typical blockchain was not intended to handle this massive sets of data. And there's a lack of streamlined practices for data entry among the enterprises in primary industries. So there is no generalized or standard rule for data entries. So they use their different enterprises involved in primary industries. They use their own softwares or from different vendors. So the data input, the way they input their data is very different, and it varies from enterprise to enterprises. Besides, there's a lack of understanding of how exactly blockchain would change their business process and practice, and which is basically creating a lot of polarizing views. And one of the reasons for this, because there is absence of strong visible use case. So the potential enterprises, they might be realizing, oh, blockchain could probably help me to solve this problem. But then again, since there is no strong visible cases, they are not really interested to adopt, such technologies. And lastly, there's a lack of regulation and legislation to recognize blockchain application like digital currency in New Zealand, and which we believe is one of the major impediments towards blockchain adoption in New Zealand. Now let's look at some of the economic opportunity of blockchain in New Zealand. Gartner predicts that blockchain will generate an annual business value of over 175 billion by 2025. And in the Asia Pacific region, it is expected to grow and earn a revenue of 4.59 billion by 2023. And it has the potential to contribute to the rising digital economies in Australia and New Zealand, which are worth nearly 149 billion New Zealand dollar combined. Besides, Gartner predicts that the spending on technology services, product and service in New Zealand will reach 13.9 billion. So we can see there are some economic opportunity for the technology service providers in New Zealand, but there is a risk alert because Gartner also predicted by 2023, 90% of blockchain-based supply chain initiative will suffer blockchain fatigue due to a lack of strong use cases. So as we said earlier, probably there are many potential service providers who are willing to provide blockchain-based solution. But if they simply jump into the bandwagon without understanding their market potential, that could be risky. So we argue that technology service providers must understand their potential market and revenue opportunity before launching any new services, to tailor business needs as well as to avoid high development and implementation cost. So how we can identify the potential market and revenue opportunity? So in this paper, we employed the concept of total addressable market, and it's a market size technique representing the potential revenue opportunity for a single service provider, assuming the full market is being captured by their services. And in order to do that, we need to understand, we need to find out the total number of potential companies who are interested, to adopt this product, and then we need to determine a pricing model. So that will be the annual contract value, and we just need to multiply this with the total number of potential companies in order to calculate the total addressable market. And to find out the total number of companies and as well as the spending on technology services, it could be done in two ways. So one of them could be employing a top-down approach. The other one could be bottom-up approach. So if we want to understand like how many potential customers are there, we can rely on secondary sources, research data, and also how much they're willing to spend on a particular technology product. We can rely on these secondary sources, and we call it top-down approach. The other one could be bottom-up approach. So it means that top-down approach are basically quite broad. It might not be localized. It might not be suitable for localized situation, right? So for example, if I want to understand like how many potential customers I have in seafood industries, let's say in Auckland region. So it's very localized, right? And I might not have enough specific data for that. So in such cases, we need to headcount. We need to employ bottom-up approach rather than relying on the top-down approach. But for this paper, what we did, we basically consulted the New Zealand business demographic statistics to identify the number of potential customers. And we found that there are a total of 546,000 enterprises in New Zealand as of 2019 financial year, and among which 64,000 are in primary industries. And among 64,000, they can be like self-employed employees, self-employed enterprises as well. So as you can see from the table, we have got like nearly 45,000 self-employed enterprises. It means that there are like no other employees other than one person. And as we have seen earlier, that the spending on technology product and services in New Zealand will reach 13.9 billion. So in order to identify the annual contract value, what we did, we estimate the average spending by each enterprise, and which is $25,424 per New Zealand dollar per year. And that's how we calculate it. So that's the spending, 13.9 billion divided by the total number of enterprises, as you can see that in New Zealand. So that would be $25,000, 25,424 New Zealand dollar per year. So we already know that total number of potential companies that we need. we also know the annual contract value, right? So now in order to calculate the TAM for the primary industries, all we have to do, we have to multiply the total number of potential companies with their annual contract value. And we found that we estimated it could be 1.65 billion per year, including the self-employed enterprises. But it is fairly safe to assume that the self-employed enterprises, they will not be interested to adopt a blockchain-based solution, or at least they will have like less interest. So if we exclude them, that would be 496 million per year. To conclude, based on our review, we observed that the opportunity of blockchain in New Zealand is promising. And through our estimation, the total addressable market in the primary industries for blockchain-enabled services, we believe it may be close to 1.65 billion per year, including self-employed enterprises, and then or 496 million per year, excluding the self-employed enterprises. Additionally, the characteristics of blockchain technology are suitable to tackle some of the challenges the primary industries are facing, like food fraud and foodborne illness. But yet we observe a number of potential impediments to adoption, such as currently there is lack of strong and practical use cases, a lack of streamlined practice for data management, lack of stream understanding of the technology and its implication to the business, as well as lack of regulation and legislation. So we believe that by having an overall understanding of the market, the technology service providers will be more interested. So they will be able to see that there are some economic opportunities as well as some practical problem that could solve for the primary industries. And I believe that this estimation will help the technology service providers to see the market potential of blockchain in New Zealand primary industries. Thank you, everyone, for listening to us.
Hi everyone. Today I would like to present our papers which entitled Design and Implementation of a Real-Time Web Service for Monitoring Soil Moisture and Landslide in Lai Chau Province, Viet Nam. We are teachers from Faculty of Information Technology, Hanoi University, of mining and geology. My talk today consists of 5 parts. First one is motivation, where we present why we choose to develop the system and why the system is necessary. The second one is the base technologies that we use to develop the system. The third one is the architectures and the detailed design of the system. The fourth one is main result that we already deployed for monitoring in Lai Chau province. And finally, we conclude the paper and give some future works. The first one, why we want to build the system. The environmental and natural resources monitoring system collects, measure, and analyze the data to evaluate changes and predict the upcoming events. This system plays a very important role in protecting environments and preventing natural hazards. You can see in this slide, this is when landslide occurred, and this is very up to date, the image that in the central province in October 2020. And this landslide tracked 17 construction workers and 13 troops sent to rescue them. And now we lost them. The disaster agency said on last Thursday that the recent adverse weather has seen more than 66 people evacuated from flood and landslide-prone areas in central Vietnam, where more than 130,000 houses and around 10,000 hectares of crops and fish farm has been inundated. In the past, from 2000 and 2015, there are more than 200 flash flood and landslide nationwide, with nearly 800 people being killed or going missing. 422 other injured, economic losses up to thousands of trillions in Vietnam. You can see here in the statistic in many areas in Vietnam. Most of them in the northern province in Vietnam, but also contain in Quảng Nam and Vinh Nam province. Others is a province like Lai Chau or Hà Lao Cai is the northern province in Vietnam. This column is the number of deaths and missing. It's a huge number. Regarding to the areas, the study area of this paper, we focus on Lai Chau province, a northern province in Vietnam, which has around 400 people in residence and approximately 9,000 kilometers square. And this region has high risks of landslide and flooding, which cause many damages in both economy and human death every year. This table shows the statistics in 8 districts in Lai Chau, and we have the column of landslide. For instance, you can see here the single districts has the highest number of landslide sites, where the Thanh Nguyên has the highest number of the flood. The map shows the Lai Chau province with the high risk areas of landslide and flash flood. But then we need to monitor in real time and observe the up-to-date the result. There are some systems already provide the resident and the government and the local management to monitoring system. You can see here is the based on Web.js technology. You can observe in Lai Chau province with different layers. You can see these landslide areas. We can see also the high risk areas, and we can see the area of resident or in layer of the traffic. But this system is static. That means you cannot monitor the landslide or soil moisture in real time. Another system belongs to the Viet Nam disaster monitoring system, VNTMS. In this system, you can monitor in real time the weather, and for instance, you can see here the wind flows and also predict the storm from the Philippines. However, this system is very general. We cannot observe in detail for specific regions, especially for the province which has high risks in landslide and flash flood. For this reason, we propose a system which is suitable for local regions, for management and for residents. The system is also easy to extend and integrate with other systems, and has low cost to be deployed in the regions. For this reason, we propose to build a web service base with open source system for real-time monitoring. The technologies that we use to build in this system including Node.js, PostgreSQL, JSON, GeoJSON, and Socket.js. Node.js is open source cross-platform. We provide a lot of modules in developing server-side and network system. Node.js applications are written in JavaScript, a lightweight integrated and modular script language for web pages, and can be run in various operating systems like macOS, MS Windows, or Linux. About the database, we use PostgreSQL, which is a powerful open-source object relation database with reliability, security, high robustness. We also use JSON and GeoJSON, which are data interchange format. JSON consists of an ordered set of name and value pair. Socket.io is built on top of WebSocket and Node.js. We have two components with us, Node.js server and a JavaScript client libraries. It provides real-time bidirectional event-based communication mechanism between client and server. We already defined some use cases for the system, for end user, for developer or other system, for external system. One user like local management or resident, we provide the view functions like map of landslide site, real-time data from sensor station, public weather services, result from the decision support system. We also allow the local management to set up the configuration of system, database management, and map management. Because this system is web service based, we also provide the other system like mobile system, decision support system, or other third-party application, sensor station, the web service, data for the accessing data and accessing map features. This slide shows the architecture of the system. We have here several modules. From the sensor station, we collect the data in specific place which has high risks of landslide and flash flood. This sensor station that collect the data and then send it the data via internet in the serialization message to the communication processing module. This communication processing module play a role to communicate with external systems like mobile or the other system like third party or decision support system. We also work with the socket I/O handler and also the core module of our system. The GUI module provide to the users that the graphics interface for the users, provide the functional to users. The user can use the mobile or the computer to serve the website. The core module also work with the database system in the PostgreSQL and also can load the landslide susceptibility maps data sources. Next, we clarify in detail each module. The first module is the communication module. The communication module gets sensor data in the format of JSON or JSON by HTTP RESTful. Its components also handle the query from other systems and forward the query content to the core component. The core component is the main component of the platform that acts as a bridge linking to other components. It receives the data or requests from communication component, manipulates data stored in PostgreSQL, then send back the result to communication and GUI component. GUI service. This GUI service provides end users like local government and residents in Lai Chau to access monitoring and administrative features like viewing maps, landslide size, real-time data, charts from station updating warning from the decision support system. This is the format of the serialization. We have from several fields. For instance, station ID is identification and monitoring system. We have device ID is the ID of the device in each station. We also have the GPS, latitude and longitude value of the station. Also we have a field for stamp. Also we define the param and values for a key. We contain the value such as the source modules or as module, something like this. In order to handle the real-time mechanism, we use the data triggers to handle this, and we use the socket I/O to implement. The design trigger is Fern when source module and landslide are inserted by the monitoring station. We notify the server. The platform then sends message to client using socket I/O. After getting the message from the platform, client will be refreshed. The database we define several tables in the database. For instance, we have 4 main tables like station params, live data, station param. Station table storing the data of each station equipped with IoT sensor containing station identifier, name and location of the station. Param table define monitor parameter that sensor in station can achieve. It allows users flexibly configure in each specific apply areas. Live data store data from each station with specific station param content, data packet structures with engaged by the station. This slide shows the result that already implemented and deployed for the Lai Chau province. You can see here is several. You can observe the high-risk landslide area in Lai Chau, and we put here 5 stations for real-time monitoring the source motion. This is the warning display received from the decision support system. We also can monitor in details for air moistures or land moistures or temperature or grain. You can access this system via internet via this link. It is the chance of the source moisture in file system. You can look up the charts in the durations. Okay, so we already presented a natural hazard predicting and monitoring system, like a vital for every country that help to reduce the damage of both economic and human life. This system is developed using new open source technology such as Socket.io and PostgreSQL, which is suitable and usable for Lai Chau province. In the future, we intend to integrate GIS as a component which allows to flexibly manage maps of vulnerable areas with flooding and landslides in Lai Chau province. Okay, so this is my talk. Thank you for your attention.
Good day, my name is Tung. Today I'm very pleasure to present about my paper optimizing the operational time of IoT device in cloud system. First, I would like to go to the introduction. As you might know, Internet of Things have been receiving attention for many years because of the growth in the number of devices. Recently, Cisco has introduced cloud fog computing, which takes the advantage of extensive resources in cloud and expand the computing power of network close to the end user. The architecture of cloud fog system include three hierarchical layers: edge, fog, and cloud. This is a cloud fog system architecture. You might see at the top is the data center. In the middle, we have the fog node, and at the end, at the bottom, we have the edge devices. It's explained for the cloud fog system. The edge devices in the bottom, which contain numerous sensor devices, fog node, edge node, either collect data, for example, video, temperature, noise, or perform a certain function. Data generated by IoT device can be sent to and processed at fog node nearby data sources. A fog node is connected and responsible for a group of IoT device performing data analysis in a timely manner. Cloud data center at the top of architecture is cloud layer, consists of numerous powerful servers are located in a few data center. Now I'm going to move to the analytical model for optimizing the lifetime of sensor device with multiple fog nodes. In order to minimize the complexity of fog node problem, we use simple wireless radio energy model. The formula mentions that the energy to transmit a unit of data to the destination is proportional to the square of the distance to the destination from the source node S to the destination node D. In a ground operation, every node must transmit unit of data to the fog node. It assumes that we have only k fog node. From n fog node, k smaller than n. The analytical model need to compute the optimal usage of node at fog node under the battery constraint of every sensor devices. After calculate the optimal solution, we see that the solution given by the linear programming model is not practical for the IoT device network. Every time there is a change in the network, the solution needs to be recalculated. Also, it's difficult to build LP solver inside of small IoT device. Furthermore, there are a number of IoT device and fog node, the number of fog node increase, it quickly becomes infeasible to calculate the optimal solution. Therefore, the fog node position needs to be recalculated among the IoT node so the minimum resident energy of IoT node is maximized. Therefore, we propose a heuristic method called modified link, M-link, which can be stated as below. You can see for the M-link, in every round, we select k fog node randomly from all n fog node in the cloud fog network, given the number of fog node in deck from 1 to n, S is the current cluster solution. For every round of data transmission, I random from 1 to n. Repeat for k different fork node. S is a fork node solution from the route obtained from the algorithm. Repeat until the first IoT node run out of energy. We develop a number of simulation in Visual Studio C++, simulate the performance of modified link. We also calculate the optimum solution. We use the LP solution. The coefficient for the linear programming problem for different sensor network topology are generated from a program called Generate Coefficient written in C++. In the program, every possible combination of k fork node from n fork node is generated, and the energy used of sending data from all IoT device to each combination of fork node are calculated. In the simulation, 100 random network, each network contain 100 nodes are generated. Each node begin with 3 million units of energy. The algorithm MLIC is run over network topology, while the number of fork node k is set to 3 and the number n is set to 5. The system lifetime is recorded for the number of cluster heads. It is a network topology coefficient. And it is a topology. It is a simulation result we have. As you can see, for our heuristic solution MLIC, it achieved around 0.9 of the optimum solution, about 90%. This is quite a good result we obtained. And it is a simulation result diagram with 100 topologies. In conclusion, also we can formulate the solution as a linear programming solution and obtain the optimal solution. It is impractical to find the solution for larger network. Therefore, heuristic algorithm need to solve the problem. Heuristic method consider lifetime of network as a number of rows. Each row is a duration of time. Send unit data and the fork node are reallocated among all fork nodes from row to row. A heuristic method MLIC and then propose 100 random 100 node network used to evaluate the performance of the method. Thank you for listening.
trends. In this talk, we will consider the list of content, the following content. What is context awareness? Intelligent system plus context awareness define smart system. What is context aware system? And new research trends. What is context awareness? Context awareness appreciated as CA refer to system can both send and react based on their environment. The system may have information about the circumstances under which they are able to operate and adapt their behavior accordingly based on rules or an intelligent stimulus, such as a part of a smart computing environment. Currently, context has been considered as a part of a process in which users are involved, hence specifying and developing context model are needed to support context-aware application to adapt into cases, tailor the set of application-relevant data, increase the precision of information retrieval, discover services, make the user interaction efficient, or build smart environment. Context related to human factor is structured into three categories: information on the user social environment, and user task. Likewise, context related to physical environment is structured into three categories: location, infrastructure, and physical condition. What is the smart system? What the smart system is defined by intelligent system plus context awareness. Intelligent system is system based on rules. Rules is the set of if-then structure. What is the context-aware system? Context-aware systems are concerned with the acquisition of context, abstraction, and understanding of context and application behavior based on recognized context. In some applications, user activity and location are crucial. Context awareness has been concentrated more deeply on location awareness and activity recognition. Three important aspects of context are where you are, who you are with, and what resources are nearby. Context awareness has attracted increasing attention in computing and communication community, since it allows automatic adaptation of devices, system, and application to user context change. Context is information related to the situation of entity, such as the present status of people, places, things, and device in the environment. An entity is a person, device, places, or object relevant to the interaction between user and application, such as location, time, activity, and services. Context awareness allows the customization or creation of application to match the preferences of individual user based on context, such as enterprise environment or home network. New research trends. New research trends in context-aware computing is the emotion awareness. Emotion awareness will help to understand how emotion influence processes such as decision making or reasoning. However, emotion acquisition remains to be complex and challenging tasks, mainly regarding the following aspects: sensing morality, data analysis, and its application in real life. An important goal of wearable computing is integrate computing computer devices into user everyday life seamlessly. This allows context-aware application to gather information about user to support them in their daily tasks. A newly attractive source of information for wearable computing is provided by mobile devices, wearable devices, and progressive sensor, able to detect the emotional state of user. In many real-world scenario, it's essential to use a wearable sensor embedded in the mobile devices, such as smartphones and smartwatches, to measure the emotion state of the user. This would help to understand how emotion influence processes such as decision making and reasoning. However, emotion recognition remains to be complex and challenging tasks, mainly regarding the following aspects: sensing morality, data analysis, and its application in real life. Sensing morality means what to send and what kind of sensor can be used. Physical sensor in mobile devices, or biosensor in wearable devices, and progressive sensor, for example, RF sensor are currently available. Data analysis means different approaches to emotion recognition are based on different types of collected data. Application means how to effectively use the emotion information in wearable computing and context-aware application. While there have been many contributions, target some these challenges, there are still unsolved problems. We propose to explore challenges, the sensing, modeling, and recognizing of emotion by using embedded sensor in smartphone, in wearable devices, and powership sensor, for example, RF sensor for powership computing. We aim to have unique contribution addresses these challenges and to provide a discussion space to facilitate collaboration among researchers interested in emotion recognition for wearable computing. Topic of interest. Success topic includes but not limited to the following: formally modeling and verification emotion awareness in powership computing or wearable computing, algorithm of emotion detection, application of emotion. However, we also have some interest topic into three groups. First group, fundamental context awareness. Second group, context aware system. And the third group, context aware technology. In the fundamental of context awareness, we interest the following: context aware model, context aware control, context aware algorithm, context aware network, context aware computing, context awareness calculate, context awareness representation, context awareness based system logic, and context awareness reasoning formal method, context awareness based optimization in swarm intelligence, theory computational model, and algorithm in context detection computing, context awareness of context in collaboration and crowd sourcing, context recognition and AI privacy issue. In context aware system, we interest the following: routing, transport, and reliability issue of context aware system, data dissemination and replication of context awareness, application and middleware system support, mobile social network application, mobility model and statistical analysis of mobility crisis, context and social awareness mechanism and algorithm, consistent of opportunistic network with infrastructure mobile wireless network, service composition in autonomic and opportunistic network, position driven information processing and decision making, government modeling, scaling laws, and fundamental limit for autonomic and opportunistic communication. game theoretic insight through operation of autonomic and opportunistic network. Participatory and advanced sensing in autonomic and opportunistic network. Trust security and reputation in context-aware system. Autonomic and opportunistic communication, test-bed and prototype. Measurement data from real experiment. Social economic model for autonomic and opportunistic communication. Mobile data measurement and collection platform for contact detection. Automatic system and model to model and detect contact. In context-aware technology, we interest the following: context-aware information retrieval, context-aware profiling, clustering, collaborative filtering, machine learning for context awareness, information retrieval, and ontology learning, context-aware e-learning or tutoring, ubiquitous and context-aware computing. Use context-aware technology in UI or HCI, context-aware advertising, documentation for mobile user, context-aware in portable devices, context-aware services, social agent and avatar, emotion and personality, visual human, autonomous actor, awareness-based animation, social conversational agent, inter-agent communication, social behavior, crowd simulation, understanding human activity, memory and long-term interaction, context representing and signal characteristic, describe and identify contact detection algorithm approaches using data collected with mobile devices, wearable devices, or coercive sensor, for example, RF sensor. User study and evaluation technique for contact detection. The novel user contact information including application of contact information for work-life balance of healthier life and behavior, integration of contact in live logging application. Thank you for your listening.
Hi everyone. Please, I could like to introduce myself. My name is Phan. I come from Ho Chi Minh City, Viet Nam. I am a lecturer and cook at Faculty of Information Technology, Nguyễn Tất Thành University, Ho Chi Minh City, Vietnam. Today, I am to present on my work here in the conference. Thank you, the organizing committee, for giving me an opportunity to present my work here in the conference. I am going to talk today my topic, proposing spatial temporal semantic data model managing genealogy and space evolution history of objects in three-dimensional geographic space. In the next slide, I will show content. My presentation is divided into the main section. Section 1, Introduction. Section 2, Objective. Section 3, Overview of the data model. Section 4, Proposing Spatial Temporal Semantic Data Model. Section 5, Experiment and Experiment Result. Section 6, Conclusion and Development. Finally, there are references. In the next slide, I will show introduction. In urban management, especially the management of structures of spatial evolution history, two-dimensional, 2.5-dimensional and three-dimensional space object of construction in the new urban area in an important and necessary work. When constructing bridges, spanning river, building smart house, keeping traces the current history at different times of construction is an important work for building constructor. This work is aimed at helping construction and constructor the opportunity to trace the spatial evolution history to 2.5 three-dimensional space object and evident to support calculation label, construction material, as well as time to complete construction time item. We can see a present new urban area in Ho Chi Minh City, Vietnam. In the next slide, I will show we have three problems to solve. Problem 1, the spatial evolution history to 2.5 three-dimensional space object at evident to support calculation of label, construction material, as well as time to complete construction item. We can see picture 3 illustrating spatial transformation bridge in spatial interval. Spatial interval. Bridge history of bridge history bridge. Finally, research. Problem 2, find and display how owned by someone in a period of time and a type of given legal time. We can see picture 12 and picture 3. The house was owned by Miss Phan Nguyen in a period of time. Incident due to storm and period of time. Problem 3, find its generation, descendant house of father house with coach. We can see 15. There are two how just found in generation trees. Can see section. Objective. The objective this paper to propose the classes such as spatial, temporal, and semantic class to construct a spatial, temporal, semantic data model for managing spatial evolution history and genealogy to 2.5 three-dimensional space object in the new urban area. This new model had ability to manage and potentially vary space over time and semantic. And algorithm find ancestor and descendant of the space object. Experimental result simulating history, spatial evolution, and geology and spatial objects so that they can apply to specific application in management construction work in the future. We can see picture below combine three class spatial, class temporal, and class semantic into SDM model to managing spatial evolution history and genealogy of 2.53 spatial objects in the new urban area. In the next slide, I will show overview of the data model. To recent spatial object to 2.53 boundary. BREP method is a good choice. This method performs a three-dimensional object based on predefined element include. We can see data model, GML model, ELUDM model, etc. The data model proposed by author from the last to recent have applied the method which include. We can see in order to data model. Yes. To represent three-dimensional object with voxel element such as pixel in two-dimensional TAS, the voxel method is the most suitable choice. This method represents a three-dimensional object based on the idea splitting an object into two elements. To represent three-dimensional object in three-dimensional geographic space, we use combine a basic three-dimensional block proposed by Minh. Yes. Model proposed by author in the past that have applied the voxel and three-dimensional block composite size method which include 1, 2, 3. We can see the model represent over three-dimensional array model, represent over object model, represent over CSV model. Command and recommendation data model. Through analysis of about the data model type, it's given us a clearly view the development history process of data method proposed by other group. We found that the model mainly use BREF method which represent 2 to 3-dimensional object basis. Predefined element include point, line, surface, solid. Through systemization and classification data model and basic criteria proposed by author mentioned above as premises for this paper to propose construction of the SGRDM to manage spatial evolutionary history. We found that above model many apply BREF method. However, in major challenge now is how to represent residential house in urban area is more detailed in spatial evolutionary history, 2-dimensional, 3.5 dimensional, 2.5 dimensional, 3-dimensional space object. From there, the manager have an opportunity to manage spatial object according to spatial evolutionary history to serve in planning future urban development policy. From the challenge, we propose constructing a TSTDM model to manage spatial evolutionary history and find the geology of place and residential building in new urban area in 3-dimensional geographic space. In the next slide, I will show proposing spatial, temporal, semantic, and data model. Time class. Time is an accessory element and information system that manage construction item. Based on the time element, people can intervene in the time to resolve urgent issue in recognizing the situation more clearly. The time element is attached to spatial data, which make the store data model abundant and more meaningful to you. We can see table 1 detail description of time data type. There are 3 type data type: event time, legal time, database time, meaning describe the time data type. We can see table 3. The table describes 9 time data units. Table 3, the table classes classify time data unit into time data type. Table 4, the table describes the relationship before and after between time data units. For example, relationship T1, T2. T1 is a unit of time beginning to occur with space object in real world earlier than the end time unit of the space object in the real world, T2. In the next slide, I will show table 5. Table describes an overlapping relationship between time data units. The semantic class, semantic data is integrated into spatial and temporal objects to express meaning using objects. Semantic are attributes that contain phrase used to explain a phenomenon, a thing, an event, a happening occurs on space and time object. For example, when we say the time of the time is the time of the event time, so must be accompanied by semantic attribute to explain the time of the event time is like. When we say the object, we have to explain what kind of object is it. What is it? Object name. It says. In the next slide, I will so combine spatial time and semantic class into SGSDM. Semantic data interested into spatial and temporal objects to express the meaning using object. Semantic are attributes that contain phrases used to explain phenomenon, a thing, an event, a happening occur on space and time object. After combining three spatial, temporal, semantic class, and then becoming a spatial, temporal, semantic data model, and called spatial, temporal, semantic data model ESTDM. ESTDM had ability to store and manage 2.5 three-dimensional spatial object in time, and semantic and illustrated by spatial, temporal, and semantic data sets. So in a section of experiment result. In addition to SGSDM also had ability to vary space over time, had the ability to query space by semantic, had the ability to query space by time and semantic, and can find ancestors and children, grandchildren of space of time. We can see data model below. Picture 7, spatial temporal semantic data model. Mannequin using mannequin spatial object to 2.5 three-dimensional. We can see class spatial class, area temporal class, and area semantic class. We can see I present building some spatial query over time and semantic. Query 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. In the next slide, we show designing algorithm by ancestor and descendant appreciation SASA and DSA. Firstly, we can see figure 4 illustrating history using the land floods. Extracting result picture 5 and set the how which could be 172 72. Table 7 list the order of the generation of the house be 172. Input data identify cost be 172. Output data unsettled research algorithm. In the next slide I will show picture 4 illustrating the history using the pilot. Yes, similar to descendant sub algorithm. Yes. Experiment result. Query spatial evolutionary history over time and semantic of object 2.5 dimensional. Experiment 1. Input freeze for me and periods. Output image of freeze and semantic description of the brick. We can see picture A. Picture B. Display semantic and image. The brick of brick with construction time. We can see picture 9. Display semantic and image a brick construction time. Yes. We can see picture 10. Image semantic. We can see picture 11. Image and semantic. Query space over time and semantic of 3-dimensional object. Experiment 2. Apply to query 2. Experiment 1 apply to query 1. Experiment 2 apply query 2. Input miss Phạm Thảo Nguyên and period of time. Output image of house and semantic describing house owned by Miss Phạm Thảo Nguyên. Yes. Experiment 3 apply to query 3. Input type of event such as output how image and semantic how after event occurs. We can see picture 13 and picture 14 image and semantic. Experiment 4 apply to query 9. We can see picture 13 and picture 14. Output input how which code BA. Output image descendant how of father how with code BA. Yes. Finally, conclusion. This paper was systematized and analysis as follow. Systemizes and analysis in detail the spatial and temporal data model. Present necessity of 3 spatial, temporal, and semantic classes to capture to construction work management in new urban area and describe detail how to incorporate the 3 new classes into construction work management into implement the construction spatial, temporal, semantic spatial data model. And this new model is called SGSDM. SGSDM is capable of managing spatial evolution history 2.5 3-dimensional spatial object, capable of spatial query over time and semantic, capable of spatial query over time, capable semantic query, and capable file unsetter and desetter of space object. The experiment result show that it's possible to apply capability of GSDM in managing the spatial evolutionary history construction work in new urban management in the future development, and in addition, this GSDM model is capable of managing various and rich objects in terms of color, set, dimensional number, and more diversified semantic interaction. There are reference acknowledgement. I'm thankful to the Faculty of Information Technology Department, Science and Technology, and especially I am very thankful to Director Bao Nguyễn Tất Thành University for its assistance to free from me completely creating this paper. Thank you so much. Thank you for your attention.
In this presentation, we will talk about modeling situation-aware formalism using VDI reasoning agent. My name is Kiran Salim and my supervisor is Dr. Hafiz Mahfuzul Haq. In this presentation, we will talk about context awareness and situation awareness, multi-agent systems, BDI reasoning mechanism, NetLogo as a simulation tool, modeling agent using NetLogo, and in the last, we will discuss conclusion and future work. Disasters, whether they are natural or man-made, these kind of situations are unavoidable. Time can play a very important role when it comes to reduce the after effects of the disaster, and it can save countless lives. People have been developing a lot of guidelines and processes to handle the disaster situations. Because of the technological advancements, significant efforts have been made due to the interest which is growing in smart and intelligent devices. There are a lot of significant effort to escape and avoid these kind of disaster situations using tiny devices along with the intelligent decision support system. What is context? Context is basically any kind of information that is helpful for us to categorize the situation of the entity. And entity, it can be a person, place, or the object. There are several categories of the context: user context, physical context, time context. Context-aware systems are those systems that acquire context information from the sensors, and sensors can be embedded in the smart devices and information system. After that, context-aware system, they perform reasoning and adapt their behavior according to the environment. Context-aware systems have a very broad domain of application for handling the complex problems in pervasive environment. Though in contrast, when it comes to situation awareness, situation-aware systems perceive the dynamic changes that is happening in the environment, and then they understand or interpret the situation and perform actions according to their surroundings. Situation awareness has gained a lot of attention in safety critical domains such as military command and control operations, or we can say in healthcare, navigation, aviation, and emergency situations. The first time the concept of situation awareness, it is introduced by Oswald in World War I. He said that you need to gain the awareness of your enemy's surrounding in order to accomplish the war. The most common definition of situation awareness that researchers have been using these days, it is introduced by Ansley in 1988. He said that it is the observation of the element present in the environment. Then you understand the meaning of the element and perform actions according to your environment. Situation awareness formal definition is broken down into three segments. The first segment is perception. It is all about gathering the information. Then you need to comprehend the situation, understand what the data means, and then you take actions to anticipate the future in projection state. When you understand or when you get aware from your surrounding, then you take decision and take action in the state of environment. It is basically the model and the cycle of the situation awareness that is mostly using in the application. In order to model situation-aware systems, agent-based technology is the most promising approach to design and implement refined software systems. An agent is basically a software program that is used to accomplish some task on the behalf of its user. An agent basically perceives its environment and take action to accomplish the specifically assigned task. Agents have their own set of beliefs to realize the situation of the world and act accordingly. In multi-agent systems, there are a set of agents where each agent has their own dedicated task to accomplish the goals. Agents can communicate with each other and they come up with a plan together to achieve the desirable goals. When we talk about agents, then we have to implement some kind of reasoning mechanism. In order to develop situation-aware systems, smart devices have been using several reasoning techniques. Among others, BDI-based reasoning technique is the most optimistic approach because of its simplistic nature and because it links with human behavior, like how humans think, plan, and make an intention to meet their desirable goals. BDA architecture presents the artificial agent that has human-like decision-making strategies based on belief, desire, and intention components. When we combine BDI mechanism and BDI reasoning mechanism with situation awareness, it leads a better decision-making mechanism. In the state of the environment, the BDI agent architecture is like whenever the sensor perceives the information, the sensor map the information related to their beliefs in order to achieve the desires. They have some set of actions in their intentions, and then they act on their intentions in order to pursue the goals. BDI is basically a classical concept to formalize the internal structure of the agent. BDI has three major concepts, or you can say component. The first one is belief. What agent think? It is the facts that are stored in agent memory, or you can say in agent internal knowledge. After that, the second component is desire. What agent wants to achieve or wants to pursue. In order to accomplish the goal, agent has some kind of intentions or set of actions that they are going to follow to pursue their desires. When we combine situation awareness with BDI agents, like I have said before, situation awareness has three segments. In the first segment, perception of element in the current situation, agents revise their beliefs related to their dynamic environment. In comprehension segment, agent observe the situation and interpret the meaning of the data that they have gathered. And after that, they select the execution plan to pursue their goals. In projection state, after selecting the execution plan, agent trigger the plan and act accordingly in order to pursue their desirable objective. In the literature, there are several approaches that have been used to handle the critical situations, such as disaster management system, safety critical system, or commercially critical systems. Though, to the best of our knowledge, when we talk about BDI agent-based intelligent decision support system, it is the concept of situation awareness. Basically, it is still lacking with BDI agents. We need this kind of approach. Why? Because we want our system to be to take intelligent decision-making capabilities when it comes to disaster situation with or without human involvement. And we need the system that acquired the current situation and interpret the situation. After that, the system is capable enough to adapt itself according to the most recent event that is occur in the environment and comes up with a plan to avoid the further mishaps. That's why we propose a BDI reasoning agent mechanism with situation awareness technique. We have used several agents in our system, and these agents are observed, or these agents are acquiring the environment situation and perform reasoning on the information data. After that, these BDI agents have their own set of beliefs along their set of actions. The BDI agents that we have used, they have the ability to identify that what kind of problem that is collected from the environment, and then they classify the context knowledge on the basis of their belief set, and then they recommend the most suitable action and select the decision mode. Because this system is designed for the complex and safety critical problem in nature, human assistant does require in this system. Therefore, our system has two modes. In autonomous mode, agent doesn't need any kind of human guidance or any kind of human assistant. But when it comes to semi-automated mode, in semi-automated mode, agent need human assistant, because if the situation gets worse or it has too many consequences, then agent do not have the capability to take appropriate actions. Therefore, human assistant is required. We have used layer architecture in our proposed solution, we have assumed that there are several sensors that is already embedded in the intelligent or smart environment, and each sensor is connected to their corresponding agent, and after getting the data, agents are going to perform reasoning on their data to interpret the meaning, and then they make strategies and they plan actions and then they communicate with each other to come up with a collaborative plan. After that, they perform action to call the rescue teams or according to the scenario in order to rescue the victims. The proposed framework consists of 3 layers: context acquisition, BDI reasoning, and agent modeling and simulation. In context acquisition layer, we have assumed that agents are acquiring the data from the sensors which are already installed in the environment to monitor the situation. Every sensor is connected to their corresponding BDI agent, like I've said before, and each agent in the system, they have their own set of beliefs related to their existing knowledge or any kind of newly acquired knowledge that they are getting from other sensors or agents. In BDI agent's reasoning layer, each agent in the system perform their specifically assigned task in order to achieve their desirable goals individually or whether if they need to collaborate with each other. Each agent has their own set of predicates, their own set of beliefs, intentions, or desires for each action that they are taking. BDI reasoning approach is goal-directed approach. BDI agents perform goal-directed tasks based on their beliefs, and whenever the situation changes, these agents revise their beliefs accordingly. In order to, whenever agent need an additional information, then agent can communicate with each other to achieve the goal state in order to fulfill the agent intention or fulfill their desires. We have developed the context-aware decision support system, and we stimulate the validity of our system in order to make sure that the system that we have proposed is able to achieve the desirable goal effectively or not. Therefore, we have used the case study of smart rescue system. We have actually in the literature, we have seen that the earthquake is the most dangerous disaster that can have several after effects such as fire or building damage, a ground rupture if the situation would not handle in time. Therefore, we have used earthquake as the evacuation system because it can generate other disasters as well. In the system design, we consider the number of intelligent BDI reasoning agents. They are monitoring the whole situation of the affected area. We have used NetLogo as a simulation tool. NetLogo basically introduced in 1999 by Yuri Volensky. NetLogo is used to design complex and reactive multi-agent multi-agents, basically multiple agents operate independently in NetLogo platform as well as collaboratively. NetLogo is already used in gaming, military, or disaster management scenarios. There are 4 types of agents in NetLogo. Turtle are these kind of agents who perform activities in NetLogo environment. Link are these kind of agents who establish the connection between turtles. Patches are these kind of agents who have coordinates to tell where the turtles are right now in the NetLogo world. When we talk about observer is a command line in which we can create and pass command to the agent to perform it directly. Reason to opt NetLogo. Basically, we have opt NetLogo because NetLogo support BDI modeling and simulation. NetLogo already has libraries that support BDI agent reasoning and communication mechanism. We have to import the BDI library in the NetLogo simulation to implement the BDI-based multi-agent system. There are several agents that we have used in our case study. For example, seismic agent is we use for calculating the magnitude of the earthquake, and the density agent it is using for allocate the human presence. Pulse agent is using to detect the damage in the building. Radon agent is used to detect the ground rupture, gas leakage, or pressure detection, you can say. This is the table of BDI reasoning agents data model. There are several BDI agents with their context acquisition that the data they gathered from the sensors, and they map the data on their belief set. And in order to achieve their desires, they have to perform their set of intentions. When we implement the prototype of a proposed system in NetLogo, let's suppose that seismic agent observed the situation and 7+ magnitude value earthquake hit. After the magnitude value, seismic agent is going to communicate with their corresponding agents. In this, we can say that seismic agent has a belief set in which seismic agent has a belief to analyze the magnitude and decide the danger level. And after that, seismic agent has the intention to check human position, alert security, check minor damage, and call rescue. Seismic agent is going to perform these set of actions in order to prevent the further mishaps of this situation. After that, the system basically immediately activate and generate alerts to all the agents in the system to perform their corresponding tasks. When the density agent get the alert of the earthquake, it exchanges the information from radon and smoke agent to observe the human presence. We can say that the radon agent detect the gas main or any leakage at site 1. Then the radon agent is going to notify the density agent to observe the human presence at site 1. And in the same case of the fire, if the fire or smoke detected, let's suppose at site 2, then the smoke agent is going to notify the density agent to check the human presence at site 2. After that, the density agent is going to notify the GPS agent and the camera agent to send the rescue and send the security team to rescue the victims. As the seismic agent shared the magnitude value with a glass break agent, the glass break agent is going to check the minor damages of the building and notify the GPS agent. Based the whole situation, GPS agent is going to notify the rescue team to rescue the victims. This is the main code sample that we have used in our NetLogo platform. This is basically the seismic agent code. In the last conclusion, basically we have proposed the BDI agent-based formalism to model context-aware decision support system that is used to handle or used to manage the disaster management. We have tried every possible execution step in order to stimulate or in order to validate the system behavior that we have proposed. In future work, we will implement our system physically using the comprehensive study, and we will use NetLogo as a middleware because NetLogo allows the API facility, or you can say the interoperability with other platforms such as Python, JSON, and MATLAB. Thank you so much for your time and your cooperation. If you have any questions, kindly you can ask.
everyone. I'm Waralak Siricharoen, and I'm so very pleased to be also one of your speaker in the ICCASA 2020, and I'm so very pleased to say hi to you all and welcome you to one of my presentation, which actually some of you probably hear it from the keynote talk as well, but as it is the one of the paper gonna be published in the proceeding. So I'm gonna give you also another versions of this idea of what we are want to experience, that what is the benefits of the using prototype mapping in design thinking process for the persona discoverings. And say hi again. You guys can call me Lak. I'm from Siricharoen University, Bangkok, Thailand. And the persona concept idea is very easy. Actually, it's just like you're trying to find one of the particular few people to represent the group of the user that you want to get to know, and do you want to use this as your target audience or your target customer if you are in the marketing area, or if you are in the software developing world, you want to find some of your target user that is very useful for your developing projects. Okay. I would like to share the screen just a bit. So the main goal of the persona is just to help someone to imagine intense user of the system. And it is important to understand whether the product is going to useful for that particular persona, as I told you before. And the persona can also help the designer in the team to learn quickly that what is their, like preferable characteristics of the person that you want to create some kind of the, like product or the software for. Not every end user that we are talking about. And then the designer creating the model that can represent the end users. Persona can also be the tool that are used in many parts of the interactions design, as I told you, for the requirement to understand the wants and the need, for the design to understand what is the person, like needs, and evaluation, detect needs that being to be encountered in the system. And for the marketing, of course, to aim the needs that already been recognized and intended for it, because this can boost up all the profits and sales. So the personas are used like in SEI as well, like human-computer interaction, because the interaction part that when you have a design that fit into some particular type of the people, it would be very useful for them to have a user experience. It's a good experience with the system. So to defining the target user, to explaining the understanding of the persona can help a lot in designing process, and also to illustrate the idea of the process in the model, also reflect the whole organization problem sometimes, because like having a persona not just only intend just to creating the new system, but also can be solving some of the problems that can be having it in the organization. You don't know who going to be the one to experience or face the problems, and how can you help them fix the problem. So also the persona can help in this particular idea by considering the differences in expectation, scope, goal, planning, and everything in the roles of needs, requirement, and necessities. This is one of the example that is kind of draw the picture for you, that when you want to describe someone, at least you have the picture, you have the characteristic, sometimes you have age, you have the preferable, we have the skill, educations, and all the hobbies, and that you can get to know one of that, persona. As a developer, would like to understand the user who are getting to use it or to see the merchandise that we are designing. So what you can dig from persona, the first one, who is the ideal customer, what is the present behavior of them and what is going to be look like, and what is the requirement or the final goals of that particular person, and what is the answer of this current problem that they, like facing and want to fix, or they hate the current situation or they like it or something like that, kind of interview, depth interviews. And when you understand the requirement of the user well, so now you can create the product and the service, and like all the transparent personality in design thinking will assess the designer to identify user need as well. So first of all, starting by defining our identity to users that designer wants to study, and their behavior well can, like gather enough data and make the ideal customer as you prefer. The one lady here, Lynn, she's very popular, Lynn Nielsen. And, like when you searching the word persona, she's going to be pop up. And this is her extraordinary ideas and model we call 10 step to persona, which is we don't necessary to use all 10. So we can have the other approach when you want to take out some of the persona. But this is some of the idea that I want to, introduce this to you. Like she have 10 steps. The first one, to gather as much knowledge that you want to in that particular product or service that you want to find your ideal customer or your ideal user that we call persona. And then you begin to create a general concept about the variance of the user. And third one, you decide whether to support or reject that assumptions about the differences of each user that they have. Which one you want to, support, which one you want to ignore it. And the third one is like you decide the appropriate number of the final persona to build based on the assumption of the different type users. And you make sure that you know enough in, 5 stage that what kind of user that you need to focus on. And the 6th, you list all the needs of that particular group of the people. And 7, you accept by the organization or reorganize the group in this stage that ensure that each team member can get possible into, like digging out and finding what is the best for that particular persona. And the 8th stage is important to decide first that we want to share this knowledge too, because sometimes the stakeholders are many in the project. So when you are in the project, so you need to have some authorization, also some plan that who is going to be the one that leading the team, or who's going to be the one that get involved with the need and requirement, who's going to want to fix the problems. So this is, you need to list the priorities of each member. And the 9th step is like create a situation for you. It will get better understanding into the problem as an individual. And the last one, then you fix it. I mean, you revise all the what you need and what you have in that particular persona, and you just adjust it as much as you want to be. So you're gonna get, like get rid of the outdated word or the new personality that you don't want to, include it into your persona, descriptions. So that is the part of finding the persona. So now we get into the second part, is empathy in design thinking. And in design thinking, they have many approach that, and it's very popular for using to find out the, like solutions or the new idea of inventions of the product or design. So in our case, I personally find some connection between design thinking and persona discovery that no one can feel what the other people do, but we will plan as close as possible to get to know that particular person. So this is the model of design thinking that have 5 main stages. The first one is empathy, define, ideate, prototype, and testing. I'm interested in empathy process because you're learning how the audience from who that you are designing for. So that is actually the part of defining persona. So I'm going in deep into, so what is this really the empathy in design thinking? So the empathy is described in the IDEO Human-Centered Design Toolkit, which is very popular and they have a deep understanding of this issue. And it's actually a reality of the persona that we are designing. So now I find the connection that if you using design thinking, you can also finding your preference, the persona or the person, the group of the people that you want to get to know. So need of the people face as well as the revealing their hidden needs and want to explain their behavior. Okay, just pause it a little bit. All right, go back. So yeah, when we revealing their hidden needs and want to explain their behavior, so it is good to have like sympathetic of the person's situation, right? Including roles and collaboration of their environment. So we got the empathy to help designer to gain the greater appreciations of that people expression and physical design. So it's so you gonna know now what drive them into what they want the best for each person. And yes, the empathy is the first step of planning design thinking process before you go into defining or determination, ideal, prototyping, and experiment or testing. So the goals of designer to be aware of what is exact, like sympathies or sympathetics of the persona which are we design and what is the problem. So in this stage, it involving directly with detecting, appealing, and giving attention to the persona which we're trying to find, So this is kind of, I see some of the beneficial as well as, like we know that get to know that experience, personal experience and motivations as being occupied with their physical situation. If you have like a scenario to walk through for that particular persona, is much better in order to explain it. So the attention that we gave into this particular group of the people or the what we created to be the persona, to understand their needs. And, it can be changed from time to time as well. Within the empathy process of the design process, designer will develop, like the whole thing, the understanding, experience, insight, observation of everything that they want to dig out. Sometimes they have the interview, sometimes they observe just sitting and watching them working, or sometimes just have a depth interview with someone as a witness of the the interview with that particular some group of the people to get what is the persona it should be. So that is, will be surprised that the persona and the team will get through this empathy method is very well. So here is some of the popular empathize method that we usually use, like AskBot, Ask 5 Whys. This is the most popular one that I use. Interview and sympathy interview. These are build the empathy by comparing and take education using photos and videos and personal journals, photos, videos, and all everything that engaging with, like this particular person, this like body storming, creating traveling map, and capture all the image, or even just give them a phone and they just take photo whatever they're interested in, so you know that what is the preferables or characters of that particular group of the people. So in the depth of that, what persona is going to be, compassion is often associated with the feelings and impartialities and advantage. So now we can feel the compassion and tend to point out what is the grief point or what is the pain point of some people. So come down to this. So we have the empathy map. It's very easy to cracking that particular person. So you have like 6, I would say, topics that we should dig out in empathy map in order to create common understanding and help them make decision. Like you have think and feel, you have see, say, do, and pain and gain. We call it the pain point and gain point, this is very popular now also in the business idea. You probably been asking a lot that what is your pain point for this product, or what is your pain point for this service? It's like the thing that you don't like and you want to fix it, or is this the gain point that you love the most, something like that. So yeah, it's gonna help you creating and come up with this kind of like map, and it's easy to update, like can focus the user experience, easy to refer to like what is specific field or what is they interested in really, and help the team think that our user is probably be the real person sometime. But for the more furthermore information, there's a persona. Usually you can have like 3 or 4 is the most that you can have. You don't need many persona because it can represent the whole group of the people, So every map character will turn into the persona, and should represent the person, and it will be easier to understand during the design process. So yeah, that's what I'm come up with the idea that when you got some, like design thinking idea, and you can come up also with the persona. So the more we know the user, it's better the product or the software will be. So that's why we can help the people in the team to get to know as much as they want in order to create the product. And user-centered design has greatly benefit people. It just have to make sure that our identity is truly true. And the personal development means living in state that they need it. And then we can improve it, like get rid of the pain point and have it more into the gain point. And this is also the benefit of the persona are a powerful, perfect way to express the design needs and helping. This is from the School of the Stanford. The first step, if you can see here, that the empathize here, they mentions that the way that you get to know the person, like interview, shadowing, seeks to understanding and non-judgmental. And then the second step in defining. When you get the empathy map, you can define. What do you can define? Just here, persona. So it is confirmed that exactly that empathy mapping, like model can help be finding the persona. So the empathy mapping, yes, actually help us think and feel. And the personal empathy mapping is the sympathy workshop activity with the team, designing team that can help you to get to know a lot about the persona. Thank you very much. I'm probably using not many minutes to talking to you guys with this, but I'm very, I would say, I'm very pleased to be in a part of the conference and wish the organizer to best in success, and hopefully next year I can join you guys again. Thank you very much. Goodbye. สวัสดีค่ะ
Hello everyone, I'm Phương Hà Đăng Bùi. I'm a lecturer at Content University. On the conference ICCASA 2020 today, I would like to present the paper Taiwanese Stock Market Forecasting with a Shallow Long Short-Term Memory Architecture, written by Phương Hà Đăng Bùi, Toàn Bảo Trần, and Hải Thanh Nguyễn. I will present the paper as follows. Introduction, Random Forest, Support Vector Regression, and Long Short-Term Memory Models for Stock Market Prediction, Experimental Results, and Conclusion. First of all, I would like to talk about the introduction. In recent years, the development of machine learning and deep learning technique has an influence on the stock market and the finance predictions. The prediction of future stock price movement have been widely researched in numerous studies. The existing approaches have focused on the construction of econometrics, statistical based on the selection of variables or forecasting models. By using machine learning techniques can help the market intermediaries to review better forecasting stock pricing. In this paper, we propose an approach based on long short-term memory model and compare the performance to the large machine learning such as random forest model and support vector regression model to forecast the task. Next, I would like to focus on using the learning models, the random forest model, the support vector regression model, and the long short-term memory model for stock market prediction. About the random forest model, random forest is a supervised learning algorithm which uses ensemble learning method for classification and regression. A random forest operates by constructing several decision trees at training time and outputting the class or mean prediction of the individual trees. In this paper, we implement random forest regression with the parameters as follows. The number of trees in the forest is 500, and the maximum depth of a tree is 4. About the support vector regression model. Support vector regression (SVR) is the combination of a support vector machine and regression. SVR is flexible to define the acceptable error in the model and will find an appropriate hyperlength to fit the data. We implement the SVR model with the regularization parameter is 0.001, the gamma is 0.1, and radar basic function kernel. Moving into the long short-term memory model. Long short-term memory LSTM is a special kind of recurrent neural networks and can be used to avoid the long-term dependency problem. The LSTM architecture contains a long short-term memory layer and a fully connected layer. In this paper, we implement the LSTM with the parameters as follows: Adam optimizer function, MSE loss function, and the learning rate is initiated at 0.001 and training LSTM on 20 epochs with a pass size of 1. Next, I will present the experimental results, the test dataset, the metrics for evaluating the performance of random forest model, the performance of support vector regression model, the performance of long short-term memory model, and the comparison between the learning models. We use the Taiwan Stock Exchange Capitalization Weighted Stock Index test dataset in our experiments. The test dataset includes the stock rise on its trading day over several years. The tests were recorded in 15 years from 1990 to 2004. We divide the dataset into two parts, where the first part of dataset is used as the training data and the remaining is used as the testing data. In specific, we use the first 9 years for training, the last 6 years for testing, the first 10 years for training, the last 5 years for testing, the first 11 years for training, the last 4 years for testing. We normalize the stock prices by rescaling the values within the range of 0 and 1. The purposes of data normalization are to enhance the numerical stability of the learning models and to reduce the training time. To evaluate the performance of learning models, we use the mean absolute error and the root mean square error. They can be computed by this equation, where n denotes the number of trading days of historical testing data, while sub I denotes the forecasted value of the historical testing datum of the test on trading day I. While sub-I hat denotes the actual value of historical testing datum of the test on trading day I, where 1 less than or equal to I and I less than or equal to N. Now, I'm going to show the performance of random forest model. The performance of random forest model on 9 training years, 10 training years, and 11 training years are shown in this table. We can see that the performance of random forest model on 11 training years is better than the others. Next, I'm going to show the performance of support vector regression model. The performance of SVR model on 9 training years, 10 training years, and 11 training years are shown in this table. The performance of SVR model on 11 training years is the highest performance, with the IMSE and the MAE are shown in this table. Turning to the performance of long short-term memory model. The performance of LSTM model on 9 training years, 10 training years, and 11 training years are shown in this table. We can see that the performance of LSTM model on 11 training years is the highest comparing to the others. Now I'm going to make the comparison between the performance of random forest model, support vector regression model, and long short-term memory model in the testing phase on 11 training years. In this table, we can see that the LSTM model is the highest performance, with the IMSE and the MAE is shown in this table, followed by the random forest model and the SVR model. We also visualize the IMSE and the MAE for comparison between the random forest model, LSTM model, and SVR model on 11 training years in this figure. Finally, I would like to talk about the conclusion. In this paper, we propose the approach with a shallow deep learning architecture based on long short-term memory for forecasting the test. We also make the comparison of the performance between deep learning approach and the classic machine learning method for forecasting tasks. The obtained results show that deep learning with long short-term memory shows an efficient prediction performance comparing to the classic machine learning such as random forest model and support vector regression model. That's all my presentation today. Thank you very much for your attention.
Hello everyone, my name is Đặng Hải Sơn and I'm working at Phạm Hùng High School in Vĩnh Long, Viet Nam. And the other three authors are Huỳnh Xuân Hiệp and Nguyễn Thanh Hải from College of Information and Communication Technologies, Cần Thơ University, Cần Thơ, Viet Nam, and Phan Anh Giang from Faculty of Information Technologies, Vĩnh Long University of Technology Education, Vĩnh Long, Viet Nam. Today we are going to present to you our study with the title, A Convolutional Neural Network on X-ray Imaging for Pneumonia Diagnosis. The application of artificial intelligence in general and deep learning in particular is becoming increasingly popular in human life. Artificial intelligence has been able to replace people in many fields. With data already synthesized and stored by computers that will have artificial intelligence become smarter. One of the areas where artificial intelligence can be applied very well is the medical field, especially X-ray imaging. In this study, we propose a convolutional network architecture to classify just X-ray images as well as apply explanatory methods to trained models to support disease diagnosis. The proposed method provides insight into medical imaging to support the diagnosis of pneumonia. Our presentation consists of 4 sections: instructions, theoretical modeling, experiment and result, and discussion. In the introduction, I give you the reason for choosing this research topic. The lungs are part of the body with the main role of exchanging gases, bringing oxygen from the air into the pulmonary veins and carbon dioxide from the pulmonary arteries. Besides, the lung also have some other secondary abilities, which have metabolized some biochemicals and filter some toxin in the blood. The lung are also a store of blood. Because the lung are the organs in direct contact with the external environment, they are very susceptible to bacteria and viruses, etc. Dry cough, cough with phlegm, difficulty breathing, with pathologies from pneumonia, bronchial tablets to more severe tuberculosis and lung cancer. In particular, COVID-19, a virus causes acute respiratory infections in humans. More than 35 million people in the world have been infected and 1 million people have died. Symptoms of COVID-19 disease appear very quickly within 14 days, and if not treated promptly, it will lead to complications such as respiratory failure, arrhythmia, blood infections, liver failure, and kidney failure, and even can lead to death. Early detection and timely treatment are the best way to prevent disease progressions and increase the patient's chance of survival. Chest radiography is one of the most common types of the diagnostic radiology exam, which is critical for screening and diagnosis of many different thoracic diseases. Diagnosing abnormality in an X-ray image requires a lot of expertise, and the qualities of the diagnosis can sometimes affect the outcome. An error may occur. Today, the applications of artificial intelligence to human healthcare is the application that is most concerned today. Machine learning, Deep learning has become an effective tool for image classification and image segmentation. In particular, convolutional networks have rapidly become a methodology of choice for analyzing medical imaging, and this is also a very effective tool for doctors to diagnose abnormalities of lung X-ray faster and faster. In our architecture theoretical modeling, most clinical techniques are based on anomaly analysis of lung X-ray images for diagnosis and treatment. Diagnosing anomalies in an X-ray image requires a lot of specialist knowledge. The quality of the diagnosis also sometimes affects the result. Error may occur. Diagnosis results are not shared, and doctors have to look back from the beginning when there is an image to diagnose. The quality of diagnosis depends on the expertise and experience of each doctor. This is a problem for doctors as the number of X-rays to diagnose increases. In places where access to skilled radiologists is limited, diagnosis of results can be delayed and affect the patient's treatment. We propose a method to classify pneumonia and normal patients from chest X-ray images with CNN architectural model. The intended method will be a good tool for diagnosing medical imaging diseases. We train a CNN architectural model that contains a convolutional class followed by a masked pooling class of 2 by 2 dimensions connected to the full class. The output of the masked pooling layer will form a 1D array that forms the matrix input for the fully connected layer. Our convolution layer contains 64 filters or nuclei. The filter itself is a 3 by 3 integer matrix. Furthermore, CNN was performed with a default learning rate of 0.000001 and ran 100 times over a period of 1 day. And we used the input of size 150 by 150, a shallow architecture that should be able to work well in the task. For our experiment, we present 3 sections: dataset description, evaluation metrics, and experimental scenarios. We experimented with Keras, an open-source neural network written in the Python language. It is run on Windows 64-bit system with aging memory. Keras has several advantages. Simple, easy to use, runs on both CPU and GPUs, and is very powerful. Therefore, we chose Keras to study. Dataset description. Talking about the chest expert dataset. Chest expert dataset is a dataset of 224,316 chest X-ray images of 65,240 patients who underwent an X-ray examination at Stanford University Medical Center from October 2002 to July 2017. Both at the control center, inpatient and outpatient treatment. We used this dataset including 2 folders, drain and vol, and each folder will be the corresponding categories: pneumonia and normal. The train folder contained 7,599 images of chest X-ray with 1,082 images of normal lung with 6,517 images of patient with pneumonia. The valve folder contained 234 images of chest X-ray with 38 images of normal lung and 196 images of patient with pneumonia. The sample of the chest X-ray image shown in Figure 3, including pneumonia in the left and normal in the right. Evaluation metrics, training and validation accuracy, area ROC and AUC. We calculated the overall accuracy, the error according to the characteristic curve ROC and AUC. Each row of matrices represents instances in a predictive class, while each column represents instances in an actual class, or vice versa. The name of the confusion matrix comes from the fact that it makes it easy to see whether the system is confusing two layers, usually mislabeled as another class. The accuracy of the model is calculated by the ratio between the total number of correctly detected lungs, normal and abnormal lung, divided by the total number of detected lung images. Experimental scenarios. Scenario 1, we have conducted on Model 1 consisting of 5 classes. The model's performance for the categorical assignment was assessed by an ACC accuracy of 0.84, shown in the figure. Scenario 2, we have conducted on Model 2 consisting of 4 classes. The model's performance for the categorical assignment was assessed by an ACC accuracy of 0.8375, shown in the figure. Scenario 3, we have conducted on Model 3 consisting of 3 classes. The model's performance for the categorical assignment was assessed by an ACC accuracy of 0.8375, shown in the figure. Result and discussion. After conducting experiment on 3 models, we have the following summary table. We see that in the above 3 models C and N, Model 1 with ACC has the best accuracy and error is very low. Therefore, we have chosen Model 1 as the training model. It is quite good for classifying abnormality on chest X-ray. Lung image recognition plays an important role in medical imaging. This helps to quickly detect serious illnesses in a lung image, especially in the current situation of the COVID-19 pandemic. Photo identification has proven to be important. The faster the disease is identified, the more effective it will be. Our study is expected to play a part in the early detection of lung X-ray abnormality. We train our CNN model with nearly exactly classified pneumonia cases during each validation. However, due to the limited resources and time, we have only been researched on the chest X-ray dataset. In the future, more in-depth study on larger datasets are expected to contribute to improving machine learning performance on medical imaging data. Thank you for your listening to our presentations.
Thank you for allowing us to present our paper at ICCASA 2020 9th EAI International Conference on Context-Aware Systems and Applications. Our paper's title is Counterbalancing Asymmetric Information, a process-driven systems thinking approach to information sharing of decentralized databases. The paper is written by Johnny Chen, Gabriel Pecco, David Sundren, and myself, Mark Hoxbergen, and all four of us are from the University of Auckland in New Zealand. I'd like to start off with a quick agenda. I'd like to talk to you a little bit about the background, our research motivation, the hypothetical company that we've created, and finally, some conclusions. So this paper explores asymmetric information and how to counterbalance it. It utilizes a case study of a hypothetical company called Hashable. The purpose of this case study is to exemplify a proposed solution to address the information asymmetry faced by buyers of residential real estate in New Zealand. The procedural response to provide the information needed to make an informed decision on purchasing a property. This paper highlights the core problems regarding information asymmetry within a transaction. It also provides a possible technological solution to counterbalance this information asymmetry. In New Zealand, the real estate market is estimated at approximately 1.1 trillion New Zealand dollars. This value is housing stock. It includes all the private sector residential dwellings and lifestyle blocks, but it does not even include vacant land. The number of New Zealand properties bought and sold in 2018 equates to approximately 200,000 transactions. And on average, a person will purchase a property only a few times in their life, and it's likely one of their largest transactions they'll ever undertake. These property transactions are often paired with mortgages and will have a lifelong impact on the individuals. This explicit information about a property is highly monitorized and becomes a crucial part of the buyer's due diligence. Yet the information presented to buyers can be hard to understand, and there are many risks that most buyers are unaware of. A property purchase transaction comes with a certain amount of stress, and logic is often subservient to emotional factors. A lot of the information about a property is given verbally by a real estate agent, and primarily consists of subjective criteria for purchasing it. They paint a tacit picture. Arman and Grant suggested that intermediaries, as i.e. the real estate agent, does not always have the best interests in mind for both the buyer and the seller. And to just give you a practical example, if you're buying a house and the real estate agent says, this is a beautiful property, you could build a beautiful swimming pool in your front yard where your grandchildren can play and swim and enjoy your retirement, that this is painting a beautiful tacit picture. But if you actually go down and delve down into it and get resource consent, whether you can actually build a swimming pool, or a geotech report on the ground stability and whether you can actually build a swimming pool, it might be a complete different picture. So explicit information and harder data is absolutely crucial to your due diligence on buying a house. The primary contribution of the problem of information symmetry faced by buyers of New Zealand residential real estate is information integration and its visibility. A buyer needs to have reliable, explicit building blocks to make an informed decision. Our research motivation. Information asymmetry between a buyer and a seller is well documented in the literature. But let us also just be specific. We are talking in the context of high-value, low-frequency transactions. Within a high-value, low-frequency transaction, often it is very hard to take advantage of the single, double, or triple loop learning that Agris and Sean came up with. As you only transact in a real estate transaction maybe once or twice in your life, you basically can't take advantage of these triple loops, double loops, and single loops. And you can't adjust your actions, change your governing assumptions or governing values. So if we look at information asymmetry, and this is also well documented in the literature, Polanyi, Akralov, Tunomi, Azal, Roland, they all come up with the fact that often a seller has the most information about a certain property or certain asset, and the buyer is kind of taking the risk when he's buying the property. The famous words, buyer beware, is a famous expression, and it's true, especially in buying and transacting in real estate. So the seller is financially not motivated to tell everything. If there's some problem that's not obvious, as soon as he discloses this information, he probably will get less for the property. And the buyer, it's his job to kind of find out all the information that he can before he actually makes the purchase. And he does that often in the due diligence period. So if we look at the tacit and explicit information flow within New Zealand, there's quite amount of explicit information. And this is often provided by specialists. Specialists as geotech engineers or builders that write building reports. They give you quite a good idea, but it's quite an expensive way of getting the information. The government provides also a certain amount of tacit information, and all these parts of information are all done individually towards the single buyer that at that moment is engaged in buying a property. But of course, as we talked earlier about the agent also provides a big amount of tacit knowledge that kind of influences decision. And once the information can be checked by a lawyer, so the lawyer is one of the people that actually checks the explicit information and gives it to the buyer, but the buyer is also influenced by all the tacit knowledge that he receives. And if everything goes well, there's no problem. But of course, if something goes wrong in the transaction, often if it comes to a conflict, it is very hard to determine what has been said, what has been taken for account. And often in that noise in the channel, this is where a lot of the confusion happens. And this is we've added the Shannon and Weaver model for communication from 1949. So if we look at the transaction, and coming back again to just the practicality of a transaction, a buyer in New Zealand signs a conditional contract in purchasing a house, and he gets a certain amount of time to do a due diligence period. And in that due diligence period, he'll often employ specialists to come up with specific reports pertaining the property. These reports are all linked specifically to the buyer. And if the buyer doesn't proceed with the sale, all the reports and all the information kind of disappear in the trash. And if someone else comes along, he'll go through the same process. And we can quickly see that lots of this information is doubled up. A lot of money is being spent on specialists and reports, and a lot of the reports are kind of wasted. So if we look at the hypothetical company that we've been talking about, we have the integration of real estate information among governments, councils, property specialists, and real estate organizations. For example, as mentioned, there may be discrepancy between a property file held at council in the form of a land information memorandum, and then there are various building experts, engineers, surveyors, and other experts who collect enormous amounts of data relating to a particular property without obligation to register this information. Often, the specialists are hired by buyer for their services during the due diligence period. And if the sale does not result in an unconditional offer and the property is relisted, this information is just lost. Also, the specialist services can sometimes be performed on a particular property multiple times by multiple specialists with different outcomes. This results in a discrepancy between the knowledge base and the average property buyer and the information presented to them, which information ultimately contributes to asymmetric information favoring the seller. So in addition, there are also lots of subjective information communication on verbal basis. As mentioned with the swimming pool, the agent can also say that the house has just been painted. This information would become much more valuable if the company names given, the date, maybe the cost of work, or a warranty that's been given. So if we can collect all this information, this will be quite an interesting addition to the way that we do our due diligence. So we've created this hypothetical company called Hashable. Of course, Hashable is from the blockchain hashing and hash 264 protocol. The purpose is to exemplify the current problems discussed, as well as providing insights to develop a procedural response of collating all the organizations needed to make an informed decision in the New Zealand real estate. This case will study and will focus on intermediary by collating information from all the various stakeholders and redistributing it throughout specialized reports to customers. So if we look at the primary activities of this company, we have an inbound data team, we have a data management team, inbound requests, and the creation and distribution of the reports. So if we look at the process of how our organization would work, is the data received involved, and the data that we receive, we verify the information. This determines the quality of Hashable's product and services. So the main activities, as discussed before, is the inbound data team that verifies the data. They determine the supplier, and if the data was sent, they are verified. The inbound team is responsible for the supplier relationship management and maintains close ties with the company's suppliers. The data management involved receipts of the extracted data from the inbound data team, which is scanned for accuracy and viruses. This data is transformed and loaded into the Hashable database, and the data management team is also responsible for locating missing and inaccurate data and communicating this back to the inbound team. This is an important activity because compromised data could result in legal challenges. For example, if a customer purchases a property based on the data supplied by Hashable and the data is inaccurate, the company could face legal proceedings. And finally, the creating of reports involves receipts of customers' orders, receiving customer orders, processing these orders, collating all the information by the inbound request team, and the inbound request team is also responsible for customer relationships. They also check whether the funds have been received by the finance department and then send a report to the customer again. The process, the team creating the report will probably be the first to notice that data what they're working with is not compromised, and this will raise an issue. And the inbound requests handle all the standardized requests. This involves checking the information, presenting, aligning with the request reports, and overall quality maintenance. So if we look at the setup of Hashable, we've done a quick CLE, and there are just 6 variables that we've used in this diagram to visualize the possible disruptive events. And for us, a security breach would be absolutely disastrous. I mean, this will infect the trust, and the trust is one of the core pillars of Hashable. Trust and the quality of data. Of course, this will influence the brand strengths, but it will also influence supplier availability. If suppliers can't trust that the information that they gave is being looked after and distributed at a very, very high level, this will influence the supplier availability, which then, of course, will affect the profitability. So in conclusion, if we look at Hashable, of course, this is based on an idea that blockchain could replace Hashable. So if we look at all the stakeholders within the real estate, and this is Land Information New Zealand, Council, Territorial Authority, Heritage, Specialists, Real Estate New Zealand, all these databases, if we can have a database protocol that would come up with specific parts of those databases that we could use, and we put it onto this blockchain, where one of the main things would be that we have different levels of attestation. So the information can be self-attested, like your swimming pool, like your paints on your house, or your hot water cylinder that you've installed. You can verify it yourself, but giving a legal tick behind that you've actually verified it yourself. So if you buy a house and the hot water cylinder has been self-attested and it's not the right date or it's not the right warranty, you have a legal possibility of going back to the owner and saying that this information was incorrect. You can have another level which says it's verified by, so the information could be verified by the owner, but also by the real estate agent, or a specialist could also verify that information. And you could have something like a government attestation, which would basically mean that it's done by the government. So this could be your rates. Your rates are the government have attested that those rates are correct, or that your title information is correct, and this would be a government attestation. Once it's been attested, it goes into a database, a decentralized database, and this could be something that over time will increase in value. As the more transactions happen, the more data gets stored on this database, the more we can use it. On top of these layers, we can build an application layer, and this application layer could be for governance for the government. It could be with decision support for the buyer. It could utilize cloud and web UI services. We could give statistical information back. And on top, we present it through official forms, legal forms. We could also verify people. We could have a dashboard that could help real estate agents with maybe average prices that are in the area, but it's also for the government, seeing whether houses comply on all kinds of things, statistical information for government, and also for buyer support. It could be a mobile presentation layer. Conclusion again, basically, if we can get all this real estate data from all these multiple sources, create verifiable reports, hopefully it'll lead to better decision making and less problems for the novice buyer. I'd like to thank you, and if there are any questions, happy to answer them.
Among the outstanding contribution to ICCASA and ICTCC 2020, the Technical Program Committee decided to choose the following two papers as best paper to win the Defeasible Award. The first one, with the title of Contextual Defeasible Reasoning Framework for Heterogeneous System, written by author Hafiz Mahfouz Ul-Haque and Sanwa Mohammed Akhtar. The second one, with the title of Two Works Service Co-Evaluation in SOA Environment or Survey, written by author Trữ Tâm, Nguyễn Văn Thảo, and Phan Vinh. Congratulations to all authors. The participants, the 9 International Conference on Contextual System Application, ICCASA 2020 ended successfully and smoothly after one day of intensive and inspiring work. On behalf of the organizing committee, we would like to express a sincere gratitude for your contribution. Special thanks go to the presenter, keynote speaker, chairs, and other discussants who have contributed a great deal to the success of the conference. We hope that all participants have found some valuable insight and begun building an active network of those deeply interested in the field of context awareness. Once again, thank you for your outstanding contribution. We look forward to work with you on future events. Best wishes.